had the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand, open arms. This is home where we are, ever strong in the world that we made. I still hear you in the breeze, see your shadow
Okay, welcome everyone, and let's see if this actually works. So, hi, hello, I'm Gunveil, and this is the livestream which I announced a few days ago, where we will be solving Beginner's Quest challenges from Google CTF Beginner's Quest. So Beginner's Quest is, maybe change this a little bit, Google's Beginner Quest is basically like an entry-level CTF, which means that the tasks are rather on the simple side. Basically, they're not like super demanding. So it's a CTF which is, I would encourage everyone who's just starting with security, starting with CTFs to play with, to get, some manual skills and also test yourself. So today's moderator is going to be, I think, Kshaku or Foxtrot Charlie or both, depending on how it works and how it will end up. And yeah, that's basically the only topic of today's stream is going to be beginners, because there are 18 challenges and I will go through all of them, same as I did with the previous live streams like this, which I did for Beginner's Quest in 2019, was it? And 2018, I believe. This time around, it's a little bit different because I actually am an author of 8 of the 18 challenges, so I do know them, and I did solve every other challenge as well. So if you think I'm going really fast and I know exactly what to do, that's because I know exactly what to do, not because I am super experienced in CTFs or security, but because I just know the challenges, right? I know how to solve them. But, we have only a couple of hours today to solve everything. So if it took you 6 hours, 12 hours, 48 hours during an actual, when you played with Beginner's Quest, then that's absolutely fine. That's okay. It's as long as you solve it, it's absolutely fine. It will, I hope, take up to 4 hours today to go through all the challenges with me explaining how to solve them. And so in a couple of cases, there will be several plausible solutions. I will present probably only one solution, but I will mention other solutions which might work as well. I will probably go for the fastest solution or the most lazy one, because on CTFs I do prefer to choose the most lazy solution, meaning it should be either fast to implement, or it should, I should just implement it, let it run in the background, and forget it. And then I go to solve another challenge when that thing finishes, which is running in the background, I basically get the flag. So that's it. Okay, let's take a look what we are doing today. Let me just do one more thing. Okay. If you have any questions, I will be looking on the chat after I solve each challenge and I will try to address the questions which are related to that specific challenge. I will skip basically questions which are unrelated to the given challenge, though if you're on our Discord, we can always chat, right? So there's that. Cool. So, okay, Google's Beginner's Quest. How to get to Beginner's Quest? You go to capture the flag with google.com/Beginner's Quest, or I think it's g.co/co/CTF. And this redirects you to this nice page, and we have Beginner Quest here on the right. So yeah, we can click it and we are here. Okay, perfect. So yeah, this is a really cool CTF in terms of how it looks like. And we have this world map, which is a little bit stylized, and we have tasks, right? And this is the task number 1, which I will begin with. And we will be basically if we look at this task, if a task has this green dashes around it, that means it's unsolved. It hasn't been solved yet. If it doesn't have these, it means it's already solved. And after a while, multiple tasks will appear on the map. So that's basically what we will be looking for, is whether the task is solved or not, by looking for these green dashes all around, or rather dashed circle. Cool. So let's start with this. Novosibirsk, chemical plant. You must wonder why we have summoned you, agent. It has come to our attention that something terrible is about to take place. There is still time to prevent the disaster, and we could not think of anyone more suited for this task than you. We believe that if you can't solve this quest, neither can anybody else. You have to travel to Novosibirsk and investigate a suspicious chemical plant. This mission must be executed in secrecy. It's classified and it regards the safety of the whole world. Yeah, as cliché as it gets, right? Therefore, we can't tell you anything more just yet. Go now, you have the fate of the world in your hands. And the first task is CCTV, and it's a reverse engineering task. You arrived at your destination. The weather isn't great, so you figure there's no reason to stay outside and you make your way to one of the buildings. No one bothered you so far, so you decide to play it bold. You make yourself a cup of coffee in the social area, like you totally belong here, and proceed to find an empty room with a desk and a chair. You pull out your laptop, hook it up to the Ethernet socket in the wall, and quickly find an internal CCTV panel. That's a way better way to look around unnoticed. Only problem is it wants a password. So this is one of the tasks I made. So and it's a simple JavaScript reverse engineering challenge. So let's maybe minimize this. We click here on the link. By the way, I believe the script for this and the whole project was actually led by Zeta2. So if you know Zeta2, yeah, you know him. He's like sometimes streaming or doing videos on YouTube. Or like playing a lot of CTFs as well, so you might know him. But there were a lot of people involved in this. So yeah, like kudos to all of them. And it would take a while to basically... does this about work? No, it doesn't yet. Maybe it will someday. Then yeah, we should get a nice list of people and credits for this event, because it was like a group effort at the end of the day. Okay, so industrial CCTV by Yes We Are Secure TM, and use the panel to log in, and we have password to log in, so we log in with something. And it says wrong password. Okay, let's take a look inside. So I'm going to press Ctrl U to show the source code. Let's make it a little bit bigger. And we immediately find this like check password routine, which is like glaringly obvious, only JavaScript present on this side. What does it do? So it gets the element ID password from the DOM, from the which like we can guess without checking that this field, right? And then it gets the value of it. Now it goes through, makes an array out of the value, and then it maps this array to, it basically gets the character code at each position and adds this OX cafe, which is a hexadecimal constant, to it. So, and this is P, and then it compares P some index to a constant, P some other index to a different constant, and so on and so forth. So basically, what we have to do is we have to reverse it, right? We have to take this, well, here we added cafe, which means that here we have to subtract cafe. And then here we converted the character into the Unicode value of this character, and well, ASCII value as well, because I do expect this to be just ASCII. And what we have to do is we have to convert it back to ASCII. So that's basically it. How are we going to do it? We are going to do it in Python. You can do it in any language of your choice. I'm going to do it in Python. Just create the challenge directory. I'm going to call it go.py, and here we go. Now you should see it. So I'm going to copy paste this. Now let's do some sublime trickery. First of all, I'm going to sort it. I'm going to press F9. Yeah, F9. And now it's sorted, right? But it's sorted not numerically, but by dictionary. So now it's fully sorted. Now what I can do is, well, I want to basically create an array of this, I guess, right? So I can remove this because it's already sorted. Now here, let me fix this as well. Let's remove this. Let's put a comma here. And I'm going to call it R, like array, right? So we have an array now. Now, for each element in the array, so for each value in the array, we go, what we do is, why is it 5 spaces? No, 2 spaces, come on. Okay, what we do is we, as I said, subtract cafe, rather, and then we convert it back to a Unicode character or ASCII character, and then we can print it. So we just do print this character, and then we don't want the end of line character here. Now I'm going to just run it. This is my Windows console. Python go py. And it says that after the coding that it's good password. So this is probably not the flag, but we can log in into the panel. So here we put good password, login, and we are in. We are in the CCTV. We can see a couple of different cameras, I guess. And we can see an important note. CTF, I just hope this is not on Showdown. So this is basically the flag format which is present in all challenges, which means that in all challenges we'll be looking for a string which starts with CTF and a curly brace, and then ends with a closing curly brace. So this is our flag, this is our solution. We do not have to do anything more in this challenge. We can just copy this flag, come here, go here, and enter the key. Enter. Yes, task completed. You have now investigated the chemical plant. Nothing seems to be out of the ordinary, even though the workers acted somewhat passive. But that's not a good enough to track. Not a good enough, I don't know, clue, trace, I don't know, to track. Well, we don't track. It seems like you have a new voicemail from the boss. Hello there, agent. It seems like the corporation that owns the plant was informed by an anonymous source that you would arrive, and therefore they were prepared for your visit. But your colleague, Agent X, has already landed in Moscow. Has already a lead in Moscow. We've already booked you a flight. First class, of course. Great. In fact, if you look out the window, you should be able to see a black car arriving now, and it will carry you to the airport. Good luck. So this opened the second challenge, which is here. Are there any questions toward the first challenge? If there are, please write on either on our Discord or on YouTube chat. I'm going to spend a second looking now. Isn't there a play button? Yeah, there is a play button, however, I don't have my desktop audio hooked into my OBS, so I think I'm going to have to do the reading. Okay, I don't believe there are any questions, so we can continue to challenge number 2. It's a cold day, and the snow is falling horizontally, so I guess the wind must be pretty hard. It pierces your side. You better use those extra pairs of socks that you were strangely given by the driver. Someone is waving on the other side of the street. You walk over to her. Hi, Agent X. Hi, Agent. I'm Agent X. We found the apartment of the person that we suspect got something to do with the mission. Come along. We still don't know what the mission is really, right? And the challenge is logic lock. It turned out suspect's apartment has an electronic lock. After analyzing the PCB and looking at the chips, you come to the conclusion that it's just a set of logic gates. And it's a misc challenge, which can be anything. So let's download this. Okay. I don't believe I didn't click it. I'm going to click it once again. Okay, now it's downloaded. So I'm going to unpack it, and after unpacking it, we get this. Which is, yeah, exactly what the sign says, basically, which is these are logic gates. So we have inputs here, an output here, and the output has to be 1. The output has to be true. And the flag has to, well, we have to add CTF as a prefix with a curly brace. Then the inputs that need to be set, which you, by the way, don't see because it's below the screen. So let me fix that a little bit. Here we go. Yeah, okay, now we should be able to see it. Yeah. Inputs that need to be set. Set means the inputs that need to be 1. So we are going to have to be somehow figure out which input needs to be set to 1 or 0, and that way we will be able to to get the flag basically. If only inputs, for example, if only inputs A, B, C must be set, then the flag will be CTF ABC. Okay, this is basically another challenge which I made. So the idea here was basically that we go to Wikipedia, wiki, and we look for logic gates. Okay, and here we will find the symbols for logic gates, as well as, like, for example, AND, which I guess everyone who ever done programming knows how AND works, right? Like the logical AND. And yeah, then we have a table in case we don't know, which means that, like, for example, if the inputs are 0 and 0, then the output of the gate is going to be 0. If the inputs are 1 and 1, then the output is going to be 1. And there are a handful of these gates, being AND or NAND, NORX or XNOR, and I believe we also missed an inverter, which basically takes a 0 and returns a 1, or takes a 1 and returns a 0. I guess like almost every programming language has some of these gates as logical expressions, I guess, or logical operators rather. Cool, so now we have to basically, using this table, we have to figure out what is this, which gate doing, and figure out how do we get 1 at the end. For example, this here is an AND gate, AND. Which means that if we want to get 0 on the output, there is only one such case. And that means that both here, on this input and on this input, we need to get a 1. Well, in that case, we know that, like, here, for example, this is also an AND gate, which means that here on this input we need to have a 1, and here on this input we will also have a 1. So this is one solution, to just basically, like, go down this, this image and, like, keep figuring out where we should have a 1 and where we should have a 0, and I think that's actually the fastest solution. Another approach to this challenge would be just to implement it. Like, write a short Python script which implements this, and then brute force it, because, like, how many inputs do we have? We have 1, 2, 3, 4, 10 inputs, right? Is it 10? I do believe it's 10, yeah. So 10 inputs, which means we have, which means basically for 10 inputs we have 2 to the power of 10 possibilities, and that's like 1024 possibilities, so it would be brute forced online really fast to find the only solution basically for inputs which will give us a 1. And that's another solution. The last solution would be basically to use something more complex like SMT solver or SAT solver, and rewrite this diagram here into a SAT equation or SMT equation. Like, for example, use Z3 for Python, but that's an overkill. Let's not go there. Oh, okay, I see Dan on the chat says that that he googled for logic gate simulator, which also is an absolutely valid solution. Cool. So which way am I going to solve it? I think let's just go with just analyzing this and see what we come up with. So I'm going to copy paste this. I'm going to open MS Paint, which is the best hacker tool, as you know. Who needs Kali Linux if you have MS Paint? Okay, and I'm going to start basically like writing with, let's say, yellow. So, okay, this is an AND gate, and I know here we need a 0. Let me just note it here, and here we need here we need a 1, and there we need a 1. So let's go from the top. We know that we need a 1 here, and we need a 1 here. What is this gate? I have absolutely no idea what this gate is. However, this circle at the end means that it's going to be something inverted. So it's here it's a NOR, which means an inverted OR, which means we get a 1 only if both inputs are 0. In any other case, we get a 0. So, well, we need a 1 here, which means we need a 0 here. So we already know that A is going to be 0, and we know that we need a 0 here, and this is a NOT gate. We can scroll back here, which is basically, again, just inverting, right? Sorry, you don't see this. No. Yeah, it's just inverting. Which means if we need a 0 here, we need a 1 here. So we already have part of this solved. Now let's continue. So this was a NOR, this is another NOR, and we have something here. This is probably going to be an OR gate. Yeah, it's an OR gate. For an OR gate, oh, by the way, for NOR, we need a 0 here and a 0 here. But for the OR gate to have a 0 at the end, there is only one such case. So if we look here, on the output, there's only one 0. Everything else is a 1, which means we need a 0 and a 0 on both cases. So we need a 0 here, and on D we also need a 0. But here we have it inverted, which means we are going to get 1 on C. So already part of it, another part of it solved. Here, OR gate, again, we need a 0 at the output, which means we will get a 0 here, and we will get a 1 here. Because, again, it's just inverted. Cool. Now, we have AND gates here, and this is an AND gate as well, so we need a 1 here, and we need a 1 here. Here, this is another AND gate, right? So we need 1 here, which means that we will need this one to be set as well, and we need this one to be set as well. Let's look here. We need to get a 1 here, and we need to get a 1 here. I have no idea what this gate is, so I'm just going to check it on Wikipedia. Oh, but that's just an XOR. Which means that, in case, by the way, we know it's a 1 here already due to this line, right? So we know this is a 1 here, so for XOR to get a 1 here, we will need a 0 here. So we know this is a 0. And we know this is a 0, this is again the NOR gate. And we need 2 zeros on a NOR gate to basically get a 1, which means we get a 0 here, and that's basically the end of the challenge. So now we just, well, write down the flag. Let me open the file. We add CTF at the beginning. We get B is set, C is set, so that's BC. Then F, I, and J is set, and this is our flag. Let's see if it works or if I made any mistakes. I guess we can already turn this off. Task complete, which means it's done. So yeah, that was a pretty easy challenge, I guess. Okay, don't save. Okay, I can close this as well. Are there any questions regarding this challenge? If you're on our YouTube channel, I guess, or on our Discord, then feel free to ask, and I'm going to answer any questions related to this task. I'll take a look in a second, and now let's just read through the solution, or rather the scenario which showed after the solution. Well, it's a rather gloomy and messy apartment. A faint shade is cast from the almost covered master window upon the worn wall. It smells very burnt, and there's a cracked bottle in the sink that suggests some kind of experiment. Okay, someone must have left in a hurry. Thinking about it, do you want to look at the beautiful view of the Kremlin from the window, or search the apartment thoroughly? And we have we can go either to task number 3 right now, or task number 4. So let's start with task number 3. And it's now look at the Kremlin. The Moscow Kremlin is really something else. But hey, wait, look at the street. Someone just started to run when they saw you in the window. Could it be the person that we were looking for? You exit the building and you see that they are jumping on a motorcycle and they take off. You spot a parked car, hotwire it, and quickly take up the chase. So this is the third challenge. And let's continue with it. The person drives into a narrow back alley, and despite the danger, you try to continue on and give chase. It is impossible to see who they are, clothed all in black and a helmet covering the face. You need to intercept them somehow. And the challenge is high-speed chase. It's also a misc challenge. You chase them through the city streets until you reach the highway. The traffic is pretty rough for a car, and you see them gaining ground. Should you have hotwired a motorbike as well? Yeah, you should probably. Too late for that. You look around your car and you spot anything useful, and you notice that this is actually one of the new self-driving cars. You turn on the autopilot, pull out your laptop and connect to the system, and enter the not-so-hidden developers mode. It's time to reprogram the autopilot to be a little bit more useful in a chase. To make it easier, you replace the in-car LiDAR feed with a feed from an overhead satellite. You also display it on the entertainment system. Now, all that's left to do is to write a better control car function, which means we basically are going to be reprogramming a self-driving car. Now, yeah, I guess we can see the satellite feed on the top. This here is our car, and we have to get through all this traffic. We can write some code here to control the car. And there's also an explanation here. So the explanation is basically that we are going to be using this editor to implement the control car function, and the control car function takes one argument, which is an array, and the array basically shows us the distance from our car to the nearest obstacle. For example, if it's like, you know, beyond the road, then it's just going to be 0. The center of the car, by the way, is always 8, is always at the index 8. So for example, if our car would move here, then we would still get index 8 here. It would still be index 8, right? And everything else would just shift up. And then here, for example, we have like 21 as the distance to this car, 20 as the distance to this car, 74 as the distance to this car, and so on and so forth. So yeah, this image isn't exact, but it kind of gives us an idea what is our parameter. And now what we return with a function is we return 0 if we want the car to just drive straight. If we want to continue straight with the car, we just input 0. If we want to go, I think, left, which is like up, right? We input -1. And if we want the car to go right, which is down, we input 1. Yeah. And let's just test it. So if we return 0 and we run it, the car just goes straight and we instantly bump into another car. So yeah, exception, emergency, abort, the car would crash. I'm pretty sure the car is already crashing, but that's just my lazy programming. I'm sorry about that. So we reset, we close this exception. Now, if we change it to 1, we should drive like the car should go right, like hit basically the side of a highway. And it does. Exception would hit the curb. Okay, and if we reset it again, and if we return -1, then it would hit the ceiling, or rather the curb on the left, not the ceiling, right? Cool. So now we have the input, right, and we need to figure out how to steer our car. And let's just reset it. And the idea is pretty simple, actually, for this challenge. We have like the scans for like, you know, above our car, or rather on the left side of our car and on the right side of our car, and from the middle of the car, and we look for the place where we have the biggest distance to go. In this case, it would be here. We can go like pretty far towards this car, so we just keep straight. And then when we reach this car or reach somewhere here, right, we should have the scan available for this area as well, and we know that we can go a little bit more here. So we steer our car to the right until this empty space is somewhere, yeah, it's somewhere basically around the index 8 of our car, which is the middle of our ar. And we continue until we pass all the cars. So let's try to do this. Okay, how do we do it? Let's try like a rather simple solution first and see if it works. I did implement this challenge ages ago, so I might not remember exactly how to solve it, but let's see. Okay, first of all, if we are how to phrase, let's maybe do it like this. We are going to find the no, I think we do it like this. If scan, oh, but we have to check a couple of things. So okay, how do we basically have to find indexes which are have the maximum distance, right? So oh, by the way, we know that the indexes are from 0 to 16, which is perfect. Okay, so I'm thinking if we should do a scan of the whole array, or instead of that, should we just like focus if like these 3 are the longest, then we just stay here. But okay, let's do it like this. So what we need to find is the index which has the maximum length. I'm going to call it maybe what programming language is it? It's JavaScript. Okay. So maximum distance and maximum distance I, and I'm going to set it to some huge value first. Well, I know, let's just set it to scan array from 0, and I, let's set it for 0, and now we just iterate through the array from 1, because we already have 0 covered, until or equal, less than 17. Okay, and now if max distance is less than scan array on that index, which we are currently considering, it's not less, it's more. No, yeah, it's less. This one is more. So we find a place which is where the distance is actually longer, so we probably should move there, right? In that case, we just do max distance is equal to this, and max distance I is equal to I. Okay. And now we should find the max distance, basically. So there are now a couple of cases. First of all, we are already driving at something which has the max distance. So, which basically means that max distance is equal to a scan array of 8, which is the center of the car. In that case, we just drive straight. We don't do anything else. So we do return 0 here. And then we have two other cases. The max distance I is actually less than 8, which means it's on the left side of our car. So in that case, we should probably steer upwards, like steer on to the left. And yeah, the other case is actually like, yeah, we probably should. Let's just do this. Max distance of I is actually more than 8. Then we should probably return 1 to go to the right side. And let's see how this goes. And we hit. So, but the car was starting to basically turn to the proper side. Let's try again. No, we are still doing something. Oh, right, because we do have the max distance here now, right? But we don't have the max distance fully. Like, okay, so the max distance actually to drive straight, the only case where we drive straight is we have all the car, like if we look at this image again, right? The car has like, the left headlight of the car is index 7 and the right headlight is the index 9. So we have to drive straight, we basically have to have both of these be the maximum distance. And 9. Okay, and that's it now. We reset. And let's maybe do 1 and see what happens. And here I'm going to leave it. Okay. I think we nailed it. Yeah, it's quite a lot of cars, right? But it's going really fast. So we can probably catch whoever is like in front of us on the motorbike. Yeah, and we get the flag. So I'm going to copy this flag. Let's see if the flag works. And the flag works. So that's basically it. Why is this important? I don't know. I thought 0 isn't good here, so let's maybe try 1 here. I didn't really have any solid reason to change it. I just thought that the car is not moving when it should, so that's why I changed it to 1. If you want me to explain the logic, I don't know. I would probably like change it to -1 if it wouldn't work, and then I would start thinking of what I'm actually doing. So that was just a hunch. There are, by the way, multiple ways to solve it, and I'm going to show you another solution which I had when I was testing this. So was this challenge? Was it this? Yeah, okay. So this is another solution which I used when I was testing the challenge. As you can see, same loop as we implemented. And then I was checking basically if we are, I was just checking like if we should move left or right like this. So that was also a bit, I guess, better. Yeah, I was checking if our car like, this is the only part which is different than our stuff, because this is identical to these two ifs. So this is checking if should our car move a little bit to the left or a little bit to the right, and this is what these two are doing. And that's the only difference, so I think our solution right now is a little bit simpler. Dominic, thank you for the donation. Dominic says, I hope you feel better, stay safe, Gunvel. Thank you, I do feel a little bit better right now, it's way better than it was some time ago. So for this solution, I did see people who actually like were code golfing this, and it was like just a few liner for them to solve it. But there's another way to solve this challenge which I'm not going to go into, and that's to reverse engineer it. Now, if you go to the top of the challenge, it says, note that this is a programming challenge, not a reverse engineering challenge. It's way easier to solve it in an intended way by writing the code. That said, I'm assigned, not a cop, which means that, yeah, you can absolutely solve this challenge. And if you want a, let's say, like medium grade reverse engineering challenge, or maybe like medium easy grade, then try it. I'm not going to spoil it to you. The code is not obfuscated in any way, but there is a trick here. So you'll have to figure it out. But yeah, let's not spoil it. Now, a couple of more things. During the CTF, or actually like even in this version, if the car, like let's just go and yeah, let's just do this again. If the car would drive too close, or rather shift too fast after the cars, then it would actually say like that, yeah, you're probably cheating, which you weren't cheating, but my anti-cheat in this game, yeah, I didn't find this during testing, so sadly it wasn't too great. There's a donation from Mogul. I'm sorry, I'm going to kind of butcher your name. Mugunthan Balaji Patabi. I'm sorry. I need to learn how to properly pronounce all the names, I guess. Happy to see you. You are back with good health. Yeah, I'm happy to be here as well. Okay, are there any questions towards this challenge? Let me know. Okay, I'm looking through the chat. Okay, I don't think there are any questions. So, okay, you're closing in on the motorcycle, but before you have time to act, the person turns to a small path, which is impossible to follow by car. You will never see them again, but wait, they dropped something, a small bag. You look inside, and you see what looked to be like an ancient amulet. You return to Agent X, and she tells you that the amulet can be a lead, and that you should return to the base to begin some research. So, from 3 we can go to 5, or we can kind of backtrack, but let's just go like through one graph right now. So I'm going to go from 3 to 5. And we somehow ended up in Istanbul, right? Yeah, that was 3, yeah, and now we're 5. It's a hot day and your skin is cracking and dry. It's difficult to make your way through the crowded bazaar. A high-pitched voice pierces through the soundscape from a salesman that's trying to sell colorful fabrics, and then from another corner comes some delicious smells. You spot a hand waving. It's your contact that you've been waiting to meet. Take a seat, my friend. I'm Gokhan. Have you been to Istanbul before? No, really? I'm sure that you'll have a great time here. I've ordered tea for the two of us. Show me the amulet, will you? Now, this is really something from my younger days. This is as mysterious as it's beautiful and belongs to the Cloaked Brotherhood. They are very dangerous, and even though your quest is urgent, I would advise you to not continue looking for the owner of this. Go home and forget about it. In the blink of an eye, 4 tough guys show up, and you start to run together with Gokhan through the crowded marketplace, and then up on the rooftop. Yeah, it's like totally a spy movie. The tough guys are closing in, but the two of you climb down from the rooftop, run around the corner, and you're able to hide in 2 crates. And the challenge we get is a twisted robot, which is, I guess, not fully related to the story. We found this old robocaller. It basically generates random phone numbers to spam. We found the last list of numbers it generated and also some weird file. Maybe it's got something to do with these new beta features that they were testing. Okay, let's take a look at the challenge. That would be challenge number 5. Okay, I probably should close this. Is there anything else? No, there's nothing more. No, the scenario was written by, I believe, Zeta2 and his brother. I think so. Some parts are mine. Like, the parts next to my challenges are mine, but that's it. Like, everything else was, like, I think made by Zeta2 and his brother. And maybe also other authors from of other challenges. I'm actually not sure here. Cool, did I download it? Yeah, I downloaded it. So what we get? We get, let me maybe open some console. It's going to be a Windows console again. So we can, I guess, close this. Okay, we get 3 files. We get robocaller 1337 py, we get a list of numbers, and we get the secret enc. Now, excuse me, this is the source code. This is the numbers which are generated. There are, how many numbers do we have? Whoa, it's quite a lot actually. Okay, 624. And we also have this secret file which looks like this, but I guess like it's a binary file, so let's look in a hex viewer at it. And yeah, pretty high entropy. Is probably encrypted or encoded in some weird way, which we have no idea yet. Okay. Now, let's read through the code. What do we have here? Okay, we have a menu and we have a main. Okay, while true, run menu. Okay, perfect. Welcome to the robocaller. What would you like to do? Generate a new list of numbers, encrypt a super secret in beta, or decrypt, or we do not have decryption because it's in beta. Yeah, stay tuned for this awesome feature. So we can only encrypt, not decrypt. We have a way to, we open a file which we have, right? This is the generated file, which means that they actually run this application and then they call either option 1 and then option 2 because we have both of these files, right? Or the other way around. We have no idea whether they called like first option 1 and then option 2 or option 2 and then option 1. And this might be actually important later on. So we have to remember about this. Okay, and it writes the output of generate random numbers and it says, okay, done, the list is saved. Or in the second case, it asks the user to input a secret. And after that, it just writes the encoded secret to the file. So let's take a look at these two functions, the generate random numbers and the encode secret. I'm going to start with encode secret because we kind of don't care about the numbers. Okay, we care about the flag, and the flag is probably going to be in the secret file. So let's go here. And what do we have here? Okay, we are generating a random key using random get rand bits. We get 8 random bits for every character in the secret. And then this is just an XOR. So this is XOR encryption with a key which is being randomly generated by using get rand bits. And right before that, we have generate random numbers, and it generates 624 numbers as we saw in the file. And what it does, it basically generates 32 bits of randomness, and then it adds to it 1 shifted by 31, which is what, 3 billion something? Sorry, 2 billion something. And then it formats the number and it appends it to the array. Now the formatting is pretty easy, it seems. It just like takes, what, it converts the number into a string, and then it takes the first 3 digits, so the top 3 digits, then next 3 digits, and then, yeah. So basically it's just like splits the numbers into digits and adds the dashes, which is rather easy. So okay, now this is a crypto challenge basically. Like, yeah, and we need to know what was generated by this random get rand bits in order to recover the key. Now you might think, hey, it's an XOR encryption, right? So XOR, like, you don't use XOR for encrypting because that's broken, everyone knows that. That's not really true. The problem is that if the key would be used, for example, the key would be just 8 bits, just 1 byte, absolutely trivial to solve. But here, every character has its own key, which is the size of the character. Like, each character is 8 bits and each key is 8 bits. And this is called OTP, one-time pad. And if this was generated correctly, like this is a crypto-secure pseudo-random number generator, this is unbreakable. There is no way, like mathematically, there is no way to break it. So we just have to hope that this is actually not a pseudo, like not a crypto-secure pseudo-random number generator, but rather just a random number generator that we can somehow break. The good news is that also we have a lot of numbers which were generated using this pseudo-random number generator, which means maybe we can do a state recovery attack. If we can do a state recovery attack, that's absolutely great. State recovery is basically like this. So if you think about a random number generator, right, it's just a black box, and the black box has a state of some size. And yeah, this is like the state, right? And after you tell it, hey, black box, give me one random number, it gives you the random number, but at the same time, it changes the state. But if we have a lot of these random numbers, maybe we can do some magical math that will get us the state at some point of this random number generator. For example, when the last number was generated, or maybe when the first number was generated. Zero, thank you for the donation. Zero says, so happy to see you as well. Yeah, it's long time, I guess. So yeah, this is basically what we will be trying to do. We have these numbers, and we need to check now what random number generator this is, but maybe we can recover the state, and if we can recover the state, then maybe we can just maybe we can just run this function again, and after we run this function again, because it's an XOR, we will actually get the flag. So this is our approach. Now, because this is a beginner's quest, we are not going to try to figure out how the math here works. We are going to check what random number generator is this, and then we are going to look for a tool which already does this for us. Perfect. So what do? We do, okay, Python random get random bits. What kind of random generator is this? So Python, we look for it, obviously in the official documentation, which should be written, and we have random get bits. This method is supplied with a Mersenne twister. This is a name of an algorithm, by the way, one of many algorithms for pseudo-random number generators. So what we are going to be looking for is state recovery. Yeah, we are going to look for a state recovery attack. And okay, first link from Google, let's just try this one. So what's going on here? Given at least 624 outputs, it can restore the internal state. Hey, how many numbers do we have again? Oh, we have 624 numbers. Hey, how convenient, right? So this is probably it, right? It's like kind of a hint for us already, but yeah, we are going kind of at this correctly. So what I'm going to do is I'm going to copy the numbers, copy the file just to archive it, and I'm going to first remove the dashes. I can just remove the dashes, because what it does, if the number was like 111, 222, 333, it just inserted dashes here, so I'm going to remove the dashes. So let's do this, and yeah, okay, so dashes are removed now. So these are the outputs from the random number generator, but they also added this here. We have to remember about this. So we will have to subtract this from each number. So maybe what we can do is we can actually do we do minus this plus, we remove it. Yeah, and now we do this, and now we say array, this is an array, and we claim this is Python actually. So I'm going to change the name of this file to Python. Robo.py, and I'm going to reopen it. Okay, so now we have this. I'm so sorry. Here we go. Okay, and now we should download this probably by the library made by Ebola. So, okay, I'm going to open my Linux console for a change. So here we go, git clone. Okay, let's just go here, and we do have the usage, an example usage, right? So I'm going to copy the robo file there as well, and I'm going to create a file called go.py. I'm going to copy paste this usage, import, what is this? So there are two files in this library, right? Recover. Okay, and this class is here in this recover, so we have to import this empty recover. Okay, so from empty recover import this class. Okay. Now we have import array from robo, rather from robo import the array, and they are recovering from their outputs, but we are recovering from our robo. So array. And what we get, it seems we get this object where we can just call get run bits. So instead of using this here, what I'm going to do is I'm going to copy paste this function, this like encode function. Because it's XOR, XOR like is, you know, mirrored, which means you can use the same function to encrypt it and decrypt. So yeah, we can, like, it's called encode secret, but it will also be able to decode secret. That being said, we also need to open the file, like the secret ends file. So let's do with open this file, read binary as file, we need to read it, and it's going to be our secret, right? Okay, now, because I'm going to pass bytes here, I don't know if this is Python 2 or Python 3, we'll have to figure it out in a second. Okay, but let's try this. Let's try print encode secret as, but the problem is that it's using random here, but we need to use this our random number generator object. Okay, now this encode is not really needed here. The list, is the list needed here? No, because we have bytes, so I think it's just fine like this. Okay, and I do believe I already have a Linux console opened. I have all these files like secret enc here, we have the robo py and go. Python go py, let's see what happens. It says unsupported for long and string, which means we... What's the string here? Where did we get the string from? Oh, because it's Python 2, let's just switch to Python 3. And here we go. Yeah, that's basically it. We got the flag. So, magic. So what happened here is basically using the numbers which we have, we ran a tool which allowed us to recover, to bring back the random number generator into a state, which it was at the end of running this. And then they run this, which means like if we run this as well, we will get exactly the same numbers, because if you have the state right, you will always get the same output. That's how pseudo-random number generators work. They basically, like, the stream of numbers, like which numbers you get one after the other, depends strictly on the state. So if we recovered the state, we were able to get the same numbers. And I do believe this is the end of this task. Oh, yeah. If I want to do, I see the question on the chat. If I want to do edits on like a lot of lines, then Ctrl-Shift-L, and now I can do edits on a lot of lines at the same time. Yeah. Okay, let's see if the flag works. So we go here, that was number 5, and it works, which means we have another challenge solved. Perfect. So, Gokhan is pointing at a parked vehicle. He tells you that you will have to try and reach it, and that if you stay where you are, you will get captured sooner or later. The guards know the neighborhood like their own back pocket, so I guess we are locals. At first you doubt the plan, it seems like a very risky option. Gokhan then finally tells you that he's not going to stay there, and that his last offer is for you to go with him. And we can either stay here or we can go with Gokhan. So let's go to number 7. Gokhan exits the crate. and makes the quick sprint for the car. The tough guys spot him when they approach. As he enters the car and tries to start it, the car makes an ominous sound as the bad guys are closing in. He looks back through the rear window and sees that the bad guys are about to jump on the back of the car and they're pulling out their guns. He tries to start the car furiously one more time and it works. Gokhan disappears off in the distance. You overhear the tough guys when they are talking about a person, Mesut, that got classified information. How convenient that we are discussing it right now. Okay. You quickly send a message to the boss to look up the person. After a short wait, you receive a response that he is currently on a private yacht in Croatia. Looks like it's time to go to Croatia, I guess. Which in our case means, I'm sorry, that was 7, right? Yeah, that was number 7. Are there any questions regarding the previous task, by the way? How does my Linux console works? If you go to Genvay Live /FAQ, you will, there is no /FAQ. Go to Genvay Live and then click on FAQ. And then look for, this part here, I believe. Yeah, like this part here, it basically describes how my Linux console works. Okay, there we go. Let's just close everything. Okay. Cool. Now let's go with task number 7. Wait. Why are we in... Yeah, we should go, wait. I think it's mixed up. Yeah, because if we want to go to Croatia, that's actually 8. Okay, let's go with 8. Let's go to Croatia. Okay, that's task number 8. Let me just create a directory for that. Okay, you arrive at the location through the coordinates that you got from the assassin. A luxurious yacht, a fat, bald man lies on a puma couch. He sips a dry martini, smokes the biggest cigar you've ever seen, and when he smiles, golden tooth is revealed. You can't help but smile back at him, although you think the place seems shady. Welcome to my yacht, Johnson. Finally, you show your face. Show us your face. Have you killed the agent now? Good. You're here to collect your reward, I presume. I'll have my guy finalize the transaction, but before you leave, I need a small favor from you. It seems that he mistook you for the assassin, which is perfect. And the challenge is hide and seek. The man hands you a pen drive, which you reluctantly connect to your laptop. He says it got it from their partner, and the partner claims that it hides valuable information in a PNG. The problem is it looks empty, so let's see if we can find anything. Okay, let's download it. Click. Okay, it's downloaded. Now, this is another challenge I made. And the PNG looks like this. Now, I know YouTube is like using a lot of compression and so on and so forth, but this is really black. There is nothing here. It's like literally black. There is no data here. This is, a steganography challenge, but there are 2 types of steganography challenges. There are either data steganography, where the actual message or the secret would be hidden inside the data, but there is no data here, so it obviously cannot be image steganography, cannot be data steganography, which leads us to the second type of steganography challenges, which are file format steganography challenges, which actually I really like. Which means we have to dig deep into how PNGs work, and we'll have to kinda dissect what we see here. Now, okay, how do PNGs work? Let's go to Wikipedia. Wikipedia is surprisingly good when it comes to like format descriptions, so we should have some format descriptions here. And what we can find here, by the way, if you are not familiar with how to process a binary file, this might go a little bit fast for you, but don't worry, like once you kind of get the understanding of how to interact with binary files, what we're doing here is pretty easy at the end of the day. Okay, let me just check. Okay, so yeah, we have a header at the beginning. We can just ignore it, we don't care about it. And then everything else is split into chunks. What does it mean? It means basically that like, let's do this. But basically the whole file is a set of blocks of data. Like one block of data is following another block of data, and then there's yet another block of data, and so on and so forth. And each block of data has their own size, and it's accompanied by the type of the data. The type of the data, like in this case being actually 4 letters, like for example ASDF, and then a checksum of so CRC 32, a checksum of the data to just to make sure that everything is fine. And that's it. Like every chunk of the data has its own type, and the length, the data, and the checksum. This is basically a typical TLV format, which is like type, length, and value. And a lot of file formats are built this way. Like PNG is one example, but like for example JPEG or TIFF are another example. So yeah, now for PNGs, PNG has a couple of chunk types. And I guess on Wikipedia we should be able to find a list of the chunk types. So it's just, yeah. These are the critical chunks. It's the header, which basically says like what's the size of the image. Then the palette, which contains color palette in case of 8-bit images, that doesn't concern us. The data, this is the image data, IDAT, and then we have IEND, which is the end. This means like end of file. And yeah, so what we should do now, and that's always the first step when dealing with PNG steganography, is to print out the chunks. And yeah, let's see like what chunks are we dealing with, and then go from there. So to do that, I'm going to create go.py. Again, Python, that's going to be Python 3. And what I need to do is I need to read this file. So open file, read binary, and I'm just going to read it. Here we go. Oh yeah. Anja's Korkami's picks for PNGs are really great as well. So Korkami PNG, and yeah, this is like a poster about what can you find inside a PNG. These are pretty amazing. Like Korkami is absolutely amazing for making these and sharing them with the community. So absolutely props to him. Perfect. So now we open the file. We ignore the header, but what's the size of the header? 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 bytes, which means we do not care for the first 8 bytes. And then while true, we go from chunk to chunk. And now let's just open a hex view of this. We have the type of the header here. So that's the like type, that's the data, which we have here. Then we have the length, I believe. Yeah, this is going to be... it's pretty large. Is this the length? No, this has to be like... What does... Sorry, I'm sorry, what... Yeah. So this has to be the length. First we have the length. So we read the length of this. Is the length... The length here is 0000D, which means this is big endian 13. So we will need to, like, let's just import struct. And we do struct unpack, which converts binary data into, like, it interprets the binary data according to how we want it to be interpreted. And we want it to be interpreted big endian, and I means a 4-byte unsigned integer. And we grab it from I to I plus 4. We get 4 bytes, and these 4 bytes are decoded as a big endian. This means big endian, and this means unsigned integer, capital I. If you are not familiar with struct unpack, just read through the documentation. But yeah, it's like almost every language has something like that. Maybe excluding C++, because you can kind of cheat your way around it in these languages. Okay, this is the type, and then we get the data, so the data, or rather the chunk data, let's maybe call it C. We get it from, I'm sorry, does the chunk data include or not include the header? We have the length, we have the chunk type, and okay. length bytes, which means it doesn't include, which is fine. So we do +8 here, and then we start the data from here, and then plus length. And then at the end of the day, what we have is the checksum, right? We have here the checksum. We ignore it. We don't care about the checksum for now. Maybe later, but for now we absolutely do not care about it. So what we do here, we just skip I plus we add 12 because of the headers, and L to get to the next chunk, and we can print this chunk. What I want to print here is let's just print the types and the length for now. And I need to open the Linux console maybe. Here we go. This is the Linux console, and let's run it in Python 3. And it says unsupported because I messed something up. Wait, what did I mess up? Which line is it? I'm sorry, C. Unsupported tuple. Where did it get? Oh, L is tuple. Right, because this returns a tuple, and we just need the first element of it. Yeah. Okay, here we go. So we see that we have like the header, image data, and then we have something called edich. Let's take a look on Wikipedia, like for ancillary chunks, for edich. There is no edich. I don't see any edich here. But you know what I see? I see that edich backwards is hide. Someone is hiding data there and wants us to spot it. And also I see that every hide has 1 byte of data. So if we look at the chunk, this part has 1 byte of data. So what is that byte? We put that byte here and see, right? So let's maybe print it out as well. Like this. But we actually, if type is equal to edich, then we print it, otherwise we don't print it. Okay, and we have some, yeah, we have some characters which end with these are ASCII characters here, right? And it ends with a equal sign, which means, hey, this smells like base 64 encoding. If you ever dealt with base 64 encoding in your life, you know that if you see at the end of a string, like formatted like this, an equal sign, that's probably base 64. Base 64 does not have to have that, by the way, but it sometimes has. So that's a good indicator. So I'm going to do something like this. I'm going to import base 64. And I'm going to just keep adding, let's just maybe do this. I'm going to keep adding to K, I'm going to be adding C, and then at the end of the loop, I'm going to print base 64D 64 decode of K. So I'm going to decode it and let's see what happens. And it says that unpack requires blah blah blah. You know what? I'm going to do one more thing. If type is equal to IEND, we just break. Oh, why don't we break? No, really. Why don't we break? Because it's byte. Oh, sorry, it's Python 3, not Python 2. Okay, there we go. And we get the flag. So that's it. Like, yeah. Again, what we had to do is we had to understand that PNG is made of chunks. Then we had to write out all the chunks. And then we had to notice that, hey, this chunk isn't standard, but it has 1 byte of data. And then we had to print that byte of data, and we have to figure out, hey, that actually looks like base 64. And then we just decode it and we get the flag. Like, concatenate this and get the flag. That's it. Perfect. Did I make this challenge? Yes, I made this challenge. Okay, and the person says to us, I see you're a person of many qualities. I must say I am impressed. One last thing, I just have to ask. See, you always struck me as a fan of sports. I don't know why. What do you prefer, basketball or soccer? And if we prefer basketball, we go to challenge number 10. If we prefer soccer or football, I guess. Well, soccer, because I'm in Europe. we go to 11. What do we prefer? I don't know. I prefer StarCraft, and it's not here, so I'm going to go with 10. But first, before we go there, do you have any questions? Would I be able to solve this question with only a hex editor? Looking here. Yes, but that would be pretty annoying. You could notice the Q here after this edit. And then if you would keep noting each letter which you find after edit, then decoded base 64, then yes, you would be able to solve it with a hex editor. It would be like harder in all honesty. Wow, that's trippy. Let's not go there. Okay. Okay. Sorry, I'm just checking one thing. We are obviously having some issues on the backend, but that's all good, all good. Okay. Perfect. Okay, let's go with challenge number 10 in that case. I think you have to solve... okay, now it works. Perfect. I think you have to solve... yeah, I think you have to solve, I don't know, like 8 challenges or 12 challenges to finish it. Perfect. We are now in New York, and New York is hot, and you are on your way to the office complex. I guess we missed part of the story, but that's fine. And you climb through the window of a side building. Inside, you spot more guards. You hide behind a desk. Now you have to sneak past the guards. And you have a challenge, a Spycam hardware. You manage to find some exposed wires and quickly hook them up to your portable terminal. It seems to be a live feed of an internal CCTV system. If you manage to decode the signal, you might be able to find something interesting. Maybe a code or a password to get the locked doors. Perfect, let's do it. Okay, now I downloaded it and it's actually 170 megs of data. And we get off CVS data. We get a lot of CVS data. We get 7 files like this, and each file is 25 megabytes. So we have something here, something here, and so on and so on. I'm sorry, what is this supposed to be again? It's supposed to be the signal of a CCTV, which means this is a like video data, right? I have no idea why this video data has so many... what is this, for example? I don't know what these are. But this part keeps changing, right? It's like from 0 to whatever. Now it's rising. Okay, so it started with 0. Is it just time? Okay, I'm going to look at the file number 6. We again start from 0, and yeah, this time seems to be just incrementing, so it's probably not super interesting. It's probably just like time. So I don't think I care about that. Okay, in that case, we have a couple of other things here, right? We have like this part, this part, this part, and this part. Cool. How do these change? You know what? I'm going to write a Python script which goes through the file and kind of tells me what are the values of each of these fields. I do not care about the first field again, but I do care about the rest. And what I'm kind of looking for is which of these values is the actual like video signal, right? Because, and what kind of video signal is this? Is it like a RGB signal? Is it like a composite signal? Is it like as video, where you have like luma and chroma separately kind of signal. So if you never played with this kind of stuff, you might want to go, for example, to Ginvale Atari, I believe, 800. Yeah, this one, like fixing blah blah blah, where I was writing a Python script. I hooked up basically with an oscilloscope and then basically a logic analyzer to a couple of pins. And then I written some Python script, and at the end of the day I dumped the image frame. So I kinda know how this kind of stuff works. And if you don't know and you never played with VGA signal or whatever signals like composite or like SVDO, this might be a little hard for you. At the end of the day, it's not super complicated. The signal is just like pixel values going from the one side of the monitor to the other, starting from the top going to the bottom, but one row at a time, one scan line at a time, right? So they go to the end of the scan line, then there is, you don't see my hand here, but it's still moving. It's so-called a blanking, a horizontal blanking period, where it like waits some time before jumping to the beginning of the next scan line, going to it, then a blanking period again, and after it goes through the whole screen, then there's a vertical blanking period where it waits some more time. So that's basically it. And if we get these pixel values, right, and the pixel values might be expressed, probably here is expressed as voltage values, right? For VGA, if I remember correctly, that would be from 0 to 7 volts. And I'm pretty sure like for composite and for SVDO, it's pretty similar like in these values. So yeah, if we figure out that, hey, these values are actually changing kinda in the range which I just mentioned from like 0 to 7 volts, then we kinda know that, hey, this is probably like just like normal frame buffer, and then we can convert it to an image and or rather to raw data, and then we will load this raw data into GIMP, for example. So let's go with it. Okay, so we open a file, right? So we have, how many files do we have? We have 7 CBS file. I'm going to do it on Windows this time because processing will be a little bit faster. So yeah, right. So we have, yeah, 7 files with this content, and so for I in range from 1 to 8 for 7 files, we have this file name, which is i.cv csv, comma separated value csv. We open the file, so with open fname, it's not a binary file, it's a text file, so as f, we read the file, we split lines, so we get one line, like we get an array of lines, and then for each line what we have to do is, let's just maybe call it lines. For each line, do we have any, we don't have a header descriptor, right? We don't. We split it by comma, so we do for ln in lines, we split the lines in by commas, but if the line, by the way, is empty, but the lines are not empty here, okay, so that's fine. So ln split with commas, and we get like, let's call it data, like d. Okay, and now, yeah, now we can operate on it. So what I want to do is, let's basically make a couple of arrays. Let's call the arrays like, from lack of a better idea, I'm going to call them XYZ 1, 2, 3, 4. Yeah, and I'm just going to be adding to this. So x append. Sorry, I'm actually going to do the array, make the arrays here. For each file separately. Yeah. And yeah, I'm going to append d from 1 to, I still need to add conversion, I do remember, don't worry, 4. So it's 1, 2, 3, 4, and that's a floating conversion, like string to float, right? So let's maybe do it like this. Okay, y, z, u. Okay, and then we print, let's print the name of the file, so let's print fname. And then we print the maximum value of x and minimum value of x. So minimum value of x and maximum value of x. The same with each x, y, z, u. Basically, this is like, you know, typical statistical analysis. I'm just like trying to figure out what I'm looking at. And I'm going to break. I want to process only one file for now, because it might take a couple of seconds to process it, because reading CSV is pretty slow. Yeah, okay. Okay, and we have the values, and the values are, yeah, not really great. I'm not really sure what kind of signal this is. But actually, like, it seems to be like, as I mentioned, VGA is like between 0 and like 0.7. So if we assume this is actually a signal which is a little bit offset, then, well, we do get this range here. That's not true for this, but it's absolutely true for this and this. So, okay, let's maybe do it like this. Let's maybe add that value to each of these, and we kind of should get the range we are looking for. Which means what we do now is I'm going to do, so k is min x for array in x, y, z, u. We are going to correct the offset, so we get min of array, and for each element in the array, so I in range length of array, we do array plus equals the minimum, but the negative minimum. So we actually add it, right? So the idea here is to bring this value to 0 and to like increase this value the same amount. Okay, so we add here the minimum. Okay. And we do it for all arrays. Let's just run it again. We should now get the range from minus. I was talking about adding the minus value, and then I never put the minus in. Okay, so this is, yeah, this is kind of, I would say, yeah, it's kind of what we are looking for. I'm going to get one more thing here. I'm going to do p is equal to max of the array. And after this, we have from 0 to max, right? To actually max plus minus k. Yeah, because k is so plus minus k. And now I have these values, and now what I want to do with the values is I want to change them into the range of a byte. A byte has a range from 0 to 255, I'm sorry. I want this value here to be mapped to 0, and this value here to be mapped to 255, and everything like linearly in between. So to do that, I'm going to take this thing and I'm going to multiply it by what am I going to multiply it by? So this 1 by this times 255 times this should give me 255. Okay, so that's good. Which means I do 255 divided by maximum, and I multiply it by this. Okay, yeah. And now I should have from 0 to 255. Let's see if that's actually the case. Yeah, okay, it's fine. It's like almost 255. Plus minus 1, that's fine. We don't care. And now what I have to do is I have to dump it to a file, and we can start looking at what we see. So to dump it to the file, I probably should do with open. How do we call the file? Let's call it fname. We are going to open it in GIMP, and GIMP likes .data extension, so we are going to do that. x.data, but here we should put also the number, and the number is I. Okay, and we open it, we write binary to it as f, and now f, we write to it bytes made from int of x, not x, I'm running out of letters, q for q in the given array, right? So actually for for x, yeah. Okay, this should dump x, and we do the same for like the rest. I'm sorry for copy pasting, you obviously shouldn't do that, but this is CTF quality code, and CTF quality code is, you can do that in CTF quality code. Here we go, z and u. And let's see what happens. Okay, and now it actually should create the files. Yeah, we have the fname. Oh, wow, fname, great. Okay, well, whatever, let's just leave it. It doesn't matter. But the I is incorrect. Why is the I incorrect? Because I overwritten. I used I somewhere else. I used I here, so I overwritten it. I'm going to use J here, because that would break my code later on. Okay, now it's better. I'm just going to remove the files which I don't need. And now let's open it in GIMP. I'm going to ignore x for now, because x had weird values, right? So I'm going to go after, I'm going to start with y, like the file named y. And okay, GIMP is starting. Any day now. Okay, GIMP has started. And this is our raw data. Now, because this is only one gray 8-bit. Yeah, this is only one stream of data, which means this is only one color. So we go for gray. And now what you do is you put your mouse here on this field and you start scrolling your mouse, because what we can see here, right, like as humans, we can see like there's a pattern here. And what you want to do is you want to keep scrolling your mouse upwards until this pattern looks like an actual image. So we are going to scroll. Yeah, and it kind of looks like an image, right? We can see already some text here, but we can also see that it's interlaced, which means that we should keep scrolling because we are currently displaying one scan line in 2 lines, and we should display it only in 1 line, so we keep scrolling. The field I'm scrolling is width, of course, right? So yeah, let's just continue scrolling. It's going to be 600 something after, because we were like 300 something first. So yeah, let's keep scrolling. No, we should keep scrolling still. No, keep scrolling. Okay, this is going well. And yeah, here we go. Hey, we have something. It's not perfect, obviously, but that's fine. Let's just increase the height as well. I'm going to put 1000 here. Okay, perfect. Hey, we are getting something. So I'm going to get maybe 1. Right, perfect. Hey, we have an image. So that's great. I'm going to open this. Now I'm going to do the same with the resolution actually should stay the same. So I'm going to open Z. And Z, as you can see, it has like the same width, and it actually corrected the height. So this is, yeah, this is probably just like red, green, blue, which is fine. That was Z, now it's going to be U. Yeah, U is a little bit more meh, but that's fine. And now let's see what X is. I have no idea what X is. So I'm going to open it, but this is X. So I think what X is X is actually the synchronization for the frames. Because like these black bars here kinda like start and end at the top of the frame. So okay, we have some frames now. Let's process all the other CSV files. I think we can absolutely ignore the X one. I don't need it, so I'm going to delete layer. Here we go. And I need to remove this break. Okay, processing. Okay, here we are. Cool, so now let's open all the other frames. I'm going to ignore the X files. I'm just going to quickly remove all the X files. Okay, and now I'm going to move all the frames here, and I'm going to keep clicking open. Okay, this is frame. Yeah, we are still like 2 frames away. Okay, here we go. So now I'm going to just hide these frames that we saw. Oh, hello. What do we have here? CTF video, and there are some question marks here. But let's just copy this. I'm going to create a notepad for myself, notepad.txt. Here we go. And that's CTF. Is it 1 or is it I? I think it was 1. PO. I can actually, like, you know, we can zoom. Video G question mark up here, and that's a 4 wise. Okay, so well, that's VGA, right? VGA is like video graphics array, I believe. So yeah, we have to kind of read what's here. Now this is a 4, and it has been written down here as a 4. This looks here as a 4 as well, so I'm just going to guess that it's RR4. And here, hey, here this looks like a capital G, right? Why is it lowercase g? Can we get a better frame? Yeah, this looks like a capital G. Yeah, absolutely. I'm changing this to capital G. And I just hope they are not doing any more like, you know, ASCII to or rather character like letter to number substitutions. I'm just going to go with video graphics array written like this, and let's see if it works. Because if it works, we can just go to the next challenge, and yeah, and it worked. So that's it. Yeah. So that was basically what you had to do. Is you had to like, yeah, like kinda play with the data to like form it in a way that it's actually, you can display it in something, and that's what we did here. And then I opened it in GIMP, use my favorite scrolling up trick. By the way, there are methods, a couple of methods to do that programmatically, like figure out what's the width, right? But this is easier. So yeah, that's why we did it. Yeah. And that's it. I think it was like pretty clear from what they said in the description about what we have to do in the task. The problem is that the CVEs where we really didn't know what we are looking at, right? The time was pretty easy to figure out, but yeah, in the chat, Razvi says that nice intuition. But it's not really intuition, right? Because if you ever played with logic analyzers and grabbing signals and processing the signal from this, then you kind of know, and it was exactly this, right? So I've done this kind of stuff in the past, so I knew how to solve it. If you haven't, that might have been a really, really hard challenge for you. Still a fun learning experience, I'm pretty sure. Cool. So we got this challenge. Congratulations, you successfully sneaked past the guards, and now you are in the main office. Look over there, a safe. Wait, it's open, no way. And it's only a photo inside? What a disappointment, but wait, don't get hasty now. It seems like a harbor in the picture, and there is something scribbled on the back. its coordinates to the harbor, which seem to be located in Singapore. I guess that's why we go to Singapore now. So we are going to 12. Yeah, that's the advantage experience gives you. That's what Rasby says. Yeah, I agree. That's how it works. And no, this wasn't a trivial challenge. It was like, I would say it was like a moderate challenge. It wasn't a hard challenge, but it was a moderate challenge. Perfect. Singapore Harbor. That's the, yeah, 12. Wait, I wanted to create a directory, not a file. Why did we have offsets of ranges noise? That's a good question. I honestly don't know. Maybe the ground, when somebody was like grabbing the signal, right, to make this challenge, maybe the ground had an offset, or the ground was incorrectly connected, or something like that. Like you connected the ground to the wrong thing. That's my thing. By the way, exclamation mark Q doesn't really work today due to unknown reasons. We might figure out someday why it doesn't work, but yeah, so I'm just trying to monitor the chat. Cool. Okay, so boy, this has been a tough journey. You had luck that you entered a box that contains some food. Wait, how did we get to the Singapore again in the box? Okay, that's perfect. That's one way to do it. You find a peaceful cafe, order a cup of tea, and charge your phone. Pling, you received another text message from the boss. I pretended that I don't know where you are, but I do. You'll have to forgive me, but I had a tracker on you all this time. You have finally reached Singapore. Find MS Revenger and sneak on board. It will take you to our enemy's hidden island. Make it quick. The ship is leaving. Okay, so we have to get to this ship. And the challenge... oh, and there is an electronic lock. So we swim towards the ship, finally reach it, climb up on the side and through a window, and we find ourselves in a cabin with a locked door, but it has an electronic lock. By the way, I do believe this is one more of my challenges. Cool. The previous one wasn't, by the way. I do believe Kevin made it. I really like the challenge, by the way. You're not sure what metal the keypad was made of, but either it was very soft or whoever punches in the code has way too much strength in their fingers. This also means you're in luck, since it's pretty obvious which digits are actually used in the 5-digit code. The order is unknown, but there can be that many possibilities, right? Note, online brute forcing is allowed in this task. Perfect, we are going to do online brute forcing. Okay. Here we go. So we have a keypad, like, yeah, I'm pretty sure, like, everyone's seen this in their life at some point, but you approach a keypad and, like, in front of a door and you see, like, which numbers are actually used and which are totally new and never touched. So this is exactly this kind of situation. So we know that this is a 5-digit code, and we know that 3 was used, 5 was used, 7 was used, 8 was used, and like 0 was used, and you can almost even make out a fingerprint here. Perfect. So we are going to write a Python script. Because first of all, we need to figure out all the permutations of this. How many permutations are there? Not a lot, I think, and my math might be lying here, but I'm pretty sure the math here is like this, so 120 combinations, not so many. Was what, like 5 factorial, right? Does Python have even like math factorial? Oh, it has, so yeah, 5 factorial, yeah. Okay, so that's basically it. Oh, by the way, and now we'll be using iter tools. That's a default Python library, which can do something like this. Iter tools permutations, and then we give it the codes, which is 3, 5, 7, 8, and 0. And it gives us an object, so let's do like for x in this, print x. Yeah, and it yeah, shows us all the combinations. So we are going to combine this with just sending a request to the website. It's not really going to be a long task. So we do this, we do this. One thing we get there is we get tuples, right? But we don't want tuples, so what we want to do is we want to join them to form a string. So we do join x. Here we go. And now we need to send a request somehow. So requests is the library to go, but not a default library, but it's a pretty popular library when you're playing CTFs and you need to send an HTTP or HTTPS request. So first of all, let's figure out how this works. I'm going to enter the code, like maybe like this. And it says, that's not it. Okay, that's fine. But yeah, here, oops. We can see that this is actually a post sent with v equals something. Like if we click view source, then yeah, this is v equals something, which is the code, and it's being sent to this address, which is fine with us. I'm just going to copy this address in that case, and then what we do is we do here we do requests post. And then we do the URL. Let's maybe make it like this. And now I never remember what next, so I'm going to just Google it. Requests, posts, Python. Here we go. There's nothing like official documentation, and we go for post. Okay, we go for data, key, and value. Perfect. So our data is going to be v. And x is the value. So that's fine, yeah. Okay, and this returns something, and text is the response of the request. So what I'm going to do is I'm going to do if CTF is in the text, then I want to print text. And that's it. Let's see if it works. Python go. Yeah, and we have a flag. We can stop it. Here we go. So that's it. Like, we just tried all the possible pins, right? What we did here is we permutated through these codes, and for each permutation we sent a post request here with v equals to this, and then we tested if CTF is actually in the text. So this is kind of like, maybe it would be not like CTF, maybe it would be a link or something. There are other ways to handle that in that case, but I would just like change this code in that case. Here we go, we have a flag. And we can continue to the next task. So we can go here, task completed. And now, after having climbed through the window, if there are any questions, by the way, related to this task, please ask on chat and I will try to address them. After having climbed through the window and unlocking the door, you enter a corridor. Hey, wait, an armed guard is patrolling your way. What are you going to do? I can hide behind a barrel, or we can try to disarm the guard. Let's just hide behind the barrel. You quickly dive in behind a barrel and try to hide from the guard. Let's hope they don't detect you, and that's task number 13. So we are going to task number 13 next. Okay, if it would be, there's a question, if it would be a heavier calculation, which means like a larger brute force, would you do it asynchronously? Kinda depends. It's like this, there's like this savoir vivre of like CTFs, which basically means that you probably shouldn't kill the server with brute forcing, which means I probably would, on a real CTF, I probably even would put a sleep there to not brute force it too hard. And it still would have to be like a small number of possibilities, like for example 1,000 or maybe 10,000. If it would be above, I would be unsure. Like for example, if it would be like 2 million possibilities, I probably would not brute force it at all. I would look for a different solution. By the way, the CTF is not over. You can go, you can play. It's also not a competition. It's just like a set of challenges for beginners. You can play at any time. There is no scoreboard, no stress. Just go and enjoy it. and it should be running, should be kept running for a long time. It's like, again, capture the flag with google.com/beginners-quest, or just Google it. Okay, task number 13. That was close. The armed guard didn't notice you. The floor shakes, the boat is leaving the harbor. You're trying to stay hidden. You see 2 guards coming your way. You sneak into a small scrubber, they pass it, but the one of the guards takes out his phones and says, "Okay, Google," and your phone suddenly makes a noise. Pling! The guards hear it. Guard 1, did you hear that? Guard 2, it must have come from the scrubber. Guard 1, let's have a look. The guards close in. You are trapped. Suddenly a bell rings in the distance. A voice talks through the speaker. Every man to their position. The ship is about to debark. I repeat, every man to their position. The guards change their course and head to their positions. Phew, that was close. You find a better place to hide and settle in for the journey. Then you noticed an internet socket in the wall. Maybe might as well sniff some traffic while there. Noise on the wire. I believe that's another of my tasks. You connect your laptop to the Ethernet socket and start Wireshark. It takes a while before something interesting pops up. Perhaps the crew was busy with whatever, and yeah, you look through the packet. So you basically get a pickup. That's the task here. Which also means one more thing. Okay, that's task number 13. Okay, so I'm going to open it with 2 tools. First of all, I get a pickup, by the way, so maybe show you. Yeah, HTTP only pickup. So that's the file. I'm going to open it first in Wireshark, and let's see what we have. So we already see like download, flag, zip, which is interesting. And then there are not a lot of packets. There are only like 54 packets. There is some WebSocket communication going on, maybe a chat or something. So before diving deeper into the packets, what I'm going to do is I'm going to run another tool, which is called Network Miner. And Network Miner is absolutely amazing. What it does, it like tries to get as much as much of data as possible from the packets. Both like by doing aggregation and also by like just extracting the files. So for example, I'm going to drag and drop the pickup. And what I get is that there were 2 hosts, and it also downloaded, like dumped to my disk 3 files, flag zip, index.html, and favicon. And I'm going to just copy these files from the download directory of Network Miner to my directory. Okay. Is there anything else interesting? No messages, credentials, sessions, no. Parameters, some parameters. I'm going to close it for now. Maybe later I will find it. So now what we have is the files, right? We have the flag zip, which was in these packets, and we have index.html and favicon, which I believe is just a 404 warning. Like, is it? Yeah, it just cannot get like, yeah, that's a 404. Cool, so let's unzip the flag, right? So I'm going to open the flag, and there's a flag txt there. Let me just do one more thing. Sorry, okay, I needed to change one thing. Okay, here we go. Okay, there's flag txt, but it actually requires a password. Yeah, it needs a password, so I don't know the password. And since I don't know the password, let's keep looking. What's in the index.html? I'm going to open index.html, I guess, in my browser. So, and this looks like to be codename, message, some chat application. Okay. So now I'm going to take a look at the source code of this. There's some nice ASCII art here. And there's like function append message, 2 hex, encrypt with military-grade encryption, decrypt with military-grade decryption, I guess, or encryption, send message, and so on and so forth. Okay, but is there any flag here? CTF or password? Password and password, okay. Let's go back to Wireshark. There was this WebSocket communication which we saw, right? There is this like switching protocols here. And then it's switching to, let me maybe do it like this. Okay, and it's switching to WebSocket, and then it has WebSocket text. Okay, and military grade encryption equals false codename goon8133 message. What's the password? What's the password to the zip file? Okay, let's look at the next WebSocket message. Badguy87, which zip file? Yeah, there are many zip files in the world. Goon1833, well, you know, the zip file. The zip file. Badguy87, oh, that one, give me a sec, need to turn on military grade encryption. Okay, there we go. And then Goon replies with okay. And then the next one we get, it's a little bit encoded. Yeah, that's all we see. So I guess we need to figure out how the military grade encryption works. Is there a network miner for Linux? I honestly don't know, but it should work under Wine, at least for pickups. Okay, so let's go, and we saw this decrypt with military grade encryption. It takes a hex string as an argument, and then it has a built-in key. So I guess we don't have to really crack anything, we just have to run this. And then it does something blah blah blah, and then it decodes. Okay, so we can use this function directly, right? So to do that, what I'm going to do is I'm going to run node, like node interpreter, and I'm just going to copy paste this function. Okay, so it's copy pasted, but the name is kind of long, right? I don't like long names. Let me move it a little bit here, so I'm going to change rather, yeah, now under X I have this. And now what we need is we need to copy this part. So copy as printable text, here we go. And now I probably need to open some notepad. There we go. Okay, what I need is just this hex string. So I'm copying it. And we do X and we run it on this. And we see zip's password is boss told me to set a better password, so this will have to do 1, 2, 3, 4. I guess you can, yeah, you can see it better now. So yeah, that was actually it. I'm going to copy paste it. Let's go here. Yeah. And then I'm going to open the flag. This is my total commander, by the way. I'm going to click F3, copy paste the password, and we get the flag. CTF, please assume this is some secret stuff. Thank you. Perfect. Okay, we can close this, we can close this, we can close this, and this. Yeah, so this was, I guess, a mix challenge, or like really simple reverse engineering challenge with pickup analysis, so with forensics, that kind of stuff. And we have it completed. Okay. You sneak off the boat and onto the secret island. When the coast seems clear, it's a small tropical island. There's guards everywhere. You sneak behind a tree and try to figure out what to do. Perfect. So that was 13, and now we go to 15. Yes, we go to 15. We don't have another option here. You're still located behind the tree, but now you have a plan on how to get in. You have taken notice that the guards are changing every 45 minutes, and when they do, you have a gap of about 30 seconds to sneak past and get into the main entrance. It's risky, of course, but you have to give it a try. You run towards the entrance. The new guards have not come yet, but suddenly you hear voices closing in. You trip and fall in front of the main entrance. Yeah. The voices are very close now, and you glimpse a code that belongs to a guard behind the corner. But at the last moment you get up and enter, only to face another door, this one closed with an electronic lock. this one brand new. The good news is that it seems that you won't be bothered for some time, and whoever is entering and leaving most likely will not notice you if you stand really still next to the wall. You pull out your handy screwdriver, unscrew the panel next to it, and stare at the circuit board for a few seconds. It doesn't look bad. You can do it. You pull out your laptop, attach some wires, and dump the firmware in seconds. It looks fairly simple, actually. And yeah, just another keypad, reverse engineering. You start to analyze the firmware and that's just a standard Linux. But this does make things easier. Imagine having to reverse engineer a custom 8051 RTOS on the spot. You browse through the directories and find the log controls and spot both the right executable and the source code. But wait, it's 3 Pascal? Note, to make the final flag, append CTF prefix and curly braces as the suffix. Okay, so a Turbo Pascal, rather a 3 Pascal challenge. And that's another of my challenges, actually. I did remember where they are, but it seems I'm stumbling upon them. Okay, so here's the source code. Decrypt all the messages. I don't think there was anything interesting in the rest of the messages there, like in the previous task. So this is the source code. No, actually that's not the source code, that's just one function, which is like check keypad code. And yeah, there's some type, which is an array of small integers, digit type. And the code is just digit type, and the function returns true or false, I guess, because it's Boolean. Now, for each digit in code, it checks whether the digit is from 0 to 9. Otherwise, it just exits. So we know that digits are from 0 to 9, which makes sense because, well, digit. And then what it does, it shifts the digit by multiply, like 4 multiplied by I, which is like 0, 4, 8, and so on. And ORs it. This is a bitwise OR, probably. So it basically takes each digit and puts it on the next nibble, hex nibble of the number. So for example, I'm guessing if the number would be, this is how you make comments in Pascal, right? If the number would be like the digits which you enter would be like this, then the number would be 1, and this is a hexadecimal, by the way, 1, 2, 3, 4, like this. Yeah, this is basically what's going on in this loop. Then it XORs it with this constant. Now here's a catch. This character in front of a number, this is, if you know C++, this is not a reference, right? It's it does not take the address of it. Instead, this is octal. Yeah, you know, like in Pascal you do like 0, sorry, in Python you do 0, 0, something else. In a lot of languages you do 0, something else. But in Pascal you actually do an ampersand. So this might catch you off guard if you don't know it. And looking at other constants, for example, here we have a dollar. So yeah, so okay, so let's maybe change this constant into something readable by humans, because while octal was the numeric, like, number system for programmers, what, like 40 years ago, it's not anymore. So now hexadecimal is. So let's do it. Let's change it to hex. Okay, yeah, this looks pretty random, actually. Okay. Why doesn't it highlight it? Well, whatever. Okay, then we do... So this is XORing the value. XORing, yeah, it's just obfuscation, probably. Then we are rolling left. That's just a normal roll assembly instruction. Then we are... Yeah, this is decimal. Oh, that's nice. That's just once. So let's change this. Then this is octal again, and I don't like octal again, so let's do hex 0, 0, this. Oh, these are just 2s, so I'm betting the next one is going to be just either 3s or 4s. Probably 4s. wait, this is the same number which was here, but it's rotated twice, which means, yeah, this is just force. So here we do, and it's the number which we had here, but it's also rotated, so it's just 8s. So, and this is with an AND. So what we are doing here is we are grabbing each bit of each digit. So we are going to have in A the lowest bits of each digit here, like in A, then the second bit of each digit in B, the third bit of each digit in C, and the most significant bit of each digit in D, or each nibble, whatever you want to call it. And then we compare these to the constants which we have here, which is cool, which means that what we have to do now is we have to put the bits together, then reverse this by rolling it right, XOR it, and then, yeah, then if we display it as hexadecimal and we reverse it, we should get the flag. So let's try it. I do believe I have, yeah, this open, so this, then we combine it with these bits, just using bitwise OR, no magic here. X and this. By the way, if this is going to work, after this XOR, all the hexadecimal value which we get should look like this. There should be no A, B, C, D, E, or F. Like they should not appear in the number if we didn't have done everything correctly because of how this works, right? Okay, so this is some value. Let's call it V. Hex V is, yeah. Now we have to roll it right. So we roll it right by 10. That's just shifting, of course. For this to be rolling, we have to do roll it by 64 minus 10 as well on the other side, and combine it using bitwise. And then, yeah, know your bitwise operations. If you know your bitwise operations, this task is easy. If you don't know, then it's a little bit problematic. So it's key here to know like how AND works, how rolling works, what XOR is, and so on and so forth. And then we have to do this. I'm pretty sure I have too many brackets somewhere. 1, 2, 3, 4. Here we go. Okay. And as I said, there should be no A, B, C, D, E, F in this, and there are because we didn't XOR it yet. So that's fine. Let's just XOR. So let's maybe do it K equals, and K we XOR it with this value, but this is a hexadecimal value. Yeah, that works. And now we have to take this value. Oh, by the way, it's Python 2. Okay. And we have to, as I said, like turn it around because of how this encoding works, what I explained here, right? We had it backwards. So we turn it around and we get this code. Now the challenge said that we have to prepend it with CTF, so CTF curly brace, this and ending curly brace. Task complete, that's it. So that's basically it, which is, again, a rather simple reverse engineering challenge. The gachas here were the ampersand for octal, and I guess you do have to understand how bitwise operations work a little bit to be able to solve it. But that's it. If you have any questions towards this, then just ask on the chat. And I do believe that was task number 15, which means we are going to task number 17. There are 18 tasks total, so that's the next to last. Okay, 17. You walk through a corridor, but hey, what was that? Changing room, you enter, find a uniform. You put it on. Whoa, you're hot in uniform. You peek outside and notice a sign on the wall says Master Office 100 meters. You close the door and plan your next steps. You're pretty close to completing your mission, but if anything goes wrong, everything you've learned will be lost. So you pull out your laptop and write down everything you know, encrypt it, hit send, and in horror watch an error appearing on your screen. You start investigating quickly and find out that a few blocks on your SSD choose this moment to die. But it gets worse. One of these blocks contained an encoding routine you needed for the data, no matter. You can implement it yourself in a few minutes, right? Playing golf, that's the name of the challenge, the misc challenge. It's actually going to be a programming challenge, I guess. Or rather, code golfing challenge. What luck, you found the official documentation of the protocol with an example implementation. But what's that? You can't write to disk anymore? What? Okay, slowly now. You find a partially writable block with 235 bytes of free space. Now we are going to have to squeeze the in the encoder.py functionality in just 235 bytes. Well, yeah, guess we have to try it. Perfect. So let's download it. And that's going to be number 17. Okay, we got 4 files now. You know what? I'm going to actually launch my Linux console this time. And what we also got is this. Let me open a notepad. Here we go. Yeah, this is a little bit weird because this isn't actually HTTP. I have no idea but there's a bug with the website. This is basically netcat. So we have to connect there and let's see what we get there. So we connect there and it says proof of work disabled. Perfect. Please send your code followed by a line containing only end. We will strip the lines for you and the time limit is 5 seconds. I guess we have to send in the encoder for the data here. So yeah. And it says yeah, like module user code has not attribute encode. So I guess we have to send it data with encode. What we can see here, this is basically a sandbox. So we know that our code is being run in a jail, which means that probably there's no escaping. Okay, so we'll have to actually do the coding. Now, we get also 4 files for this challenge. These are the coder, encoder, protocol, and tester. So let's see the protocol. Top secret, burn before reading. Agents, please send all and any intel to the drop servers encoded in the manner described in this document. The drop server will not accept any data encoded in any different way. In this explanation, we are assuming your input data is a stream of bytes not longer than 800 bytes. Step 1, type blank value. We already chatted about the type blank value when we were doing the PNG challenge. The data need to be TLV encoded. Each TLV block needs to have the following format. Bytes 0 to 3, 4 ASCII characters denoting the type, then big endian encoded length of data, like almost like PNG, but without like CRC32. The drop servers require at least 3 TLV blocks. The begin type, which is like length 26, and it has the alphabet lowercase. Then the data, followed by length data corresponding, the length and data corresponding of your input data, and then the end dot 26 with the uppercase alphabet. And then it needs to be encrypted. The data needs to be stream encrypted by XORing the byte stream output in step 2 with the following number sequence. And so this is the key. And yeah, great. The final output byte stream can be sent to the drop server, and we have also an implementation ready for us. So this is the implementation. This is the like make TLV, step 1 encode as TLV. We have all this. Then we have a decoder as well, so we can test, I guess, if it works. And we have a tester, where the tester is going to tell us if it worked or not. So let's run Python 3 tester. Okay, golf, there is no encoder, but we have encoder. We can test the encoder which we have. Yeah, and the actual encoder worked. Let's keep it, but let's change one thing. I'm going to change in the encoder here to 7, for example. Yeah, and it says begin block not found because like the encryption is broken, which makes sense. So we change it back and it works. Okay, so we have to code go this file, like the encoder, which occupies how much space? It occupies 7 kilobytes, and the we have to squeeze it in to 235 bytes. Yeah, so we have to take code, which is like 7 kilobytes of code. We have to squeeze it into 200 bytes of code. Best of luck. There are, by the way, 2 ways to solve this challenge. I'm not going to spoil the second one yet, but I will mention it later when we do another task. When we do task number 6, I believe. But we can solve this challenge normally. Okay, so I'm going to leave the normal encoder intact, but I'm going to create a file called, I'm going to copy it as encoder_golfed. And I'm going to open it. Here we go, this is the file we are going to be using, and then the tester. Okay. And let's run it. Okay, perfect. And now we just have to, first of all, let's get rid of this. Like, what is this? This looks like a sequence of integers, right? 2, 3, 5, 7, 11, 13, 17, 19. What are these? I don't know. Maybe you know, but I don't know. What I know is I know the address, or rather, how to find the online integer sequence encyclopedia. Which is the way to go if you find a weird link, like weird integers, and you need to find them. So we find them, and it says prime numbers. So these are prime numbers, right? So if we calculate a prime number, we calculate the prime numbers ourselves, then we don't have to have this table in, which is already going to save us a lot of space. So how do we do that? I guess there are like a couple of ways to do it. By the way, we don't need this. I'm going to remove it. How many numbers do we need? We don't need that many numbers, right? Because the protocol said something about there being at most 800 bytes. So yeah, so I'm going to implement finding prime numbers for x for x in range up to this is the max number they have, so let's say like 99999. We add x only if x is a prime number, right? So if is prime x, I'm going to code golf it later on, but like one step at a time, okay? So def is prime. We do oh, by the way, like we probably should skip some step as well. For I in range x, this is going to be a really like not an optimal solution, but that's fine. We do oh, by the way, from 2 to x, but without x. Okay, if I is divisible, sorry, but if x is divisible by I without any rest, any remainder, then that's not a prime, otherwise it's a prime. So I think this is going to solve our this problem. We can get rid of this already. Okay, and let's run the tester. Sorry, is the tester? Yeah, we are set to golf. So okay, let's see if it still works. Yeah, it still works. Perfect. No problems at all. Okay, so now we have, what was the size of it? Let's actually do it like this. Yeah. Okay, so it's 1000. We still have to cut off like 800, almost 900, I guess. Yeah, 900, almost 900 bytes. Okay, what do we do next? We have this make TLV, which is grabbing the output, and it has byte data. We can absolutely make this simpler, I guess. because it's doing a join here, we don't need it. What we can do here is we do return. We grab this and we add, like, keep adding stuff. And then byte data. Yeah, this is the same. It's an equivalent. It should be the same, and it should, yeah. That's another, like, almost 100 bytes saved. Then, like, the name of this, like, make TLV is like, let's call it just M, and it should save us some bytes as well. Okay, then it makes an alphabet. I'm pretty sure we can do an alphabet easier. How do we do an alphabet? And we can do an alphabet like here, for example. Let's call it just A. And that's going to be something like this. For X in range between Python. Well, that's Python. Small a is 97, so that's like 97, and z is 122, so that's 123. And this should give us an alphabet, but we need to do a join on it. Print a. Let's just do it like this. And we run it, Python 3 encoder gold dot. Okay, it's pretty slow because calculating the prime numbers like this is pretty slow. This is like, yeah, like O n squared, I believe. And for this amount, for one, yeah, but that's quite a lot of computations. Maybe we don't need to optimize it, you figure it out. Anyway, yeah, but it looks like an alphabet, I would say. So this works. Now here, oh, we actually need bytes, right? How do we do bytes? Oh, that actually saves us a couple of bytes because we just do this. And actually this, we don't need this at all, we just do range. Yeah, this should be the same. We do need to, however, do bytes here. Int found? Why? Do I need to really have a list here? I'm confused. 0 bytes like object int found. Wait, what? Okay. Wait, Python 3. What does? Okay, range from, what was it, 97 to 123. It returns a range, right? But if we do bytes, it should just give me. Oh, okay, that's even simpler. I just do bytes like this. Okay, so we have an alphabet, and it's actually like just a couple of letters. So we do this, and we exchange here. We just put A, and here, can we do A upper? How do we do A upper? Maybe it just will work automatically. And let's see if it works. It does work, and we are already under 1000, that's 965. Now this name here, step 1, step 2, that's a long name, right? And we can, by the way, do what we done before, so we can just do this plus, by the way, we are code golfing, so I shouldn't be so like generous with my spaces. Yeah, and code golfing is all about like changing the code to make it shorter. Okay, there we go. And this has a stupid name, I'm just going to call it S. But should be already like a lot of bytes less, yeah, 40 bytes less just by changing the name. And this one is going to be called X because I say so. So that's 800. And here we do... okay, what's going on here? That's just XORing. So for XORing we can... oh, data to encrypt, nice. D. we do here bytes of, and maybe this will be enough what I write. A and A, we actually have alphabet upstairs, but so maybe let's not go with A, like Q and W. I don't believe we have a Q yet, right? Yeah, no. For Q, W, and zip data and the numbers. And we'll change the numbers to something shorter, and this should be equivalent. It's just like XORing. Yeah, it still works. Now let's change the numbers to like capital N is fine. Okay. This. Okay, wait. Oh, here, right. W has to be, we have to do this on W, but it's actually shorter to do this here because we just need like bottom bytes, right? And this is actually shorter like this. Okay, let's see now. Okay, we are at 600 and we already have like the end as well, so that's fine. Cool. Now we don't need this actually. So that's 595. You can see it here. Then okay. Here obviously type is going to be T, byte data is going to be B. We can start removing the spaces as well. Here, input data as byte stream, let's just call it B. And same stuff here, let's just call it B. Okay. That's 461. Like, we still have to cut 50% of it. Okay, then here, do we really need like TLV data? No, what we actually need here is, okay, so you just return this, and this is equivalent. It does have to be called encode though. Okay, and we are kinda approaching the moment where we should have some more fun with it. So do we really need two distinct functions for this, or can we just like, yeah, we don't. We just need to do this, like, let's call it X, and let's copy paste this function here because it's just like, yeah, it just goes here. So we remove this, we remove this, we remove this. 376, and we get D is not defined. What did I mess up? Because it's not D, it's B. Okay. That's not great what just happened. I'm going to backpedal a little bit. Let's go back here. This works, right? No. Okay. Let's go back a little bit. Okay, does this work? Yeah, this works. So something changed later. Okay, let's go back here, like TT. Okay, this works. I'm going to run it 2 times in case, and it's actually like flaky. It's fine. So here, SFT, and this should work as well, and I just return it. This should be fine still. Okay, this is still fine. Now here, why did it not like me doing this? What does M take? M take bytes UTF-8. Why? Oh, because it takes. Wait. Oh, we can maybe get rid of this stuff at all by just doing like here doing T and here doing B 3 times. That should be easier. Okay, that's 389. We can remove this space, we can remove this space. Now, is there anything else we can... Okay, once again, why did it not like me doing this? Here, let's change D. And here we do this. That should be the same. Non-type is not subscriptable. I'm pretty sure this is a stupid mistake I'm doing. I'll figure it out in a sec. Wait, too much. Okay, let's keep it here. Okay. So now, how many do we have? We still have to do quite a long way to go. We can remove this space here, we can remove this space here, we can remove this space here. Okay. Now let's fix this is prime, because it's a little bit long. Okay, so instead of doing this, we can do if not any, and here put a function, which would be maybe y divided by, or no, x divided by I equals 0. For I in range up to from 2 to x. Yeah. Okay, this should work as well. And this when we can get rid of is prime function. And this is 100 to go. Well, 80 bytes even to go, not even 100. Okay, now we have a lot of returns and a lot of functions, and I don't really like it. Okay, let's do it like this. First of all, let's do this. Okay, and see if this works. Okay, this works, so I can remove this. Okay, 296, so we are pretty close. M. Yeah, M, I'm probably going to keep it like this. Then I'm wondering about this, like, can I do like from struct import? No, it's and remove this. Let's see if it changes anything in a positive way. No, it's the same. But let's keep it like this. Then, oh, I can obviously remove this here, and I can obviously do this. 288. Okay, now which variables do I have a collision with? Okay, so this is XORing, right? And we do XORing at the end. So this is the XORing, which we should do. And we should do the XORing here. Okay, it works, so I can remove another function. Okay, 272. Then we have this. We will play with this in a sec. How many ranges do we have? We have range 1, range 2, 3 ranges. So what we can do here is we can do r equals range and use r instead. R, and r. Here we go. That's another couple of bytes, 268. Okay. I wonder if we can remove these. No, we cannot. Can we change this to... Yeah, we can. If we do this and change this not any to all, then it should work still the same way, because we are like flipping two opposite conditions, which should behave the same way. So okay, 261. Is there a better way to write this? I wonder, can we just like 1e3? No, range doesn't like it. Okay. Here a space. How many bytes do we have? We have 2 bytes. Is this going to fix anything, bytes? And we just do B here, and we do B here. 260, so no, that didn't change anything, but didn't break anything either. Okay, can we somehow get rid of this function, maybe? Because that's what we are doing here, right? We are not doing anything that important. You know what? Maybe instead of doing... Because like what? Begin, we know that the length is 26. So maybe instead of doing this whole thing, we could do... like we add b, like so b begin, and then to that begin, this is the type, right? We do add the length, and the length is going to be 26, and that's big endian, so 26 or 26. No, so that's CHR. 1A, that's not great, but let's see where we get with this. Okay, and then we add A to, like, the data to it, which is the alphabet. And we can remove this. And this should still be the same. Okay, now we do the same with this part. So we do b and dot 0, 0, x 1a, because the same length, right? One more 0. 1a, okay. And now we do add the upper alphabet here. So we are one step closer to removing the function, the whole function. Okay, and here what we have to do is we have to add the b data here, then add the length, which is this. And maybe we can optimize it a little bit better in a second. And then we have to add the actual data. Okay, and then we remove this. 244, almost. Yeah, and it works, so we are very close. We obviously don't need 2 spaces here. And again, can I just copy this here? Okay. 39, but we also have this and we have a new line, so I think we are done. What we need to do now is we need to and C dash, we have to connect, we have to grab this, paste it, and done. Perfect. CTF encoding successful, Intel received correctly. Awesome. So yeah, like we took this and made this out of it, which was a fun exercise. If you've never done code golfing, I really encourage you to do, but teaches you a lot about a given language. And there are like, if you Google for code golfing, I think even on Stack Overflow there's one division like totally where they chat about code golfing. So yeah. Okay, there we go. Okay. Which means we can close this. Okay, we closed everything else. Yeah, the script looks like obfuscation from Michał. Yeah, I fully agree. It did look like obfuscation. It wasn't obfuscation though. So, okay, let's go with task number 18. But before we go there, let's do a 10-minute bio break. And then we can come back and play with it a little bit more. So, see you everyone in 10 minutes and we can do the remaining tasks, I believe. So, well, I don't have a good way to until 2049. Okay, see you then. Okay, I guess we can get back to it. Perfect. So, which task did we finish on? Master Office. Yeah, the last task. Okay. So you press a button and enter a tinted glass door. There is a vast oil painting on the wall that depicts a bald man with a scar under his left eye. I wonder if this should be like bald man or bold man, but okay. Under his arms rests a white chubby cat. Below the painting is the very same man, and he's addressing you. Well. Isn't it the troublemaker? How did you get past the guards? Well, I have a final offer for you. I'll let you live only on one condition. Start working for me. Bwahahaha. While he goes on with his monologue about conquering the world and some twisted philosophy about how he is actually a good guy, the good guy, and so on, you start discreetly fiddling with a control panel labeled self-destruction. You need to quickly figure out the activation code while he's distracted. And the challenge is a strange virtual machine reverse engineering. Everyone is coming up with their own programming languages these days, so I came up with my own architecture, so you can use it to run the attached program that will print the flag. Okay, so let's download it, and that's task number 18. It's technically the last task, however, there were like some tasks we omitted, so we'll get back to them later on. Okay, we get, in this case, 2 files. There we go. I guess we don't need this for now. We have, basically a ROM file, which is, if we do a hexdump-c, it looks kinda interesting. There's like a lot of I's, G's, and so on. It's not encrypted in any way. Because the entropy looks pretty low. However, yeah, we cannot make heads or tails of it. And we have a zip file, so or rather a tar.gz file, so let's maybe unzip that one. Tar setxvf, here we go, vm. Okay, and it's cargo and it's Ruby, no it's not Ruby, it's Rust. So let's go to vm cli, which is probably command line interface. Let's just do cargo build. And let's see what happens. It's compiling, that's good. Okay, and let's see if in the target debug VME command line interface, missing ROM, and I'm just guessing ROM file is the VM ROM, right? Okay. So, this is a very long flag, and it's getting really slow. So, what kind of challenge is this? There's the question, is this Sublime 4? Yeah, it's Sublime 4, the one I'm using. So this kind of challenge it's called an optimize me, which means that you have something which actually prints the flag, but it's super slow, so you would probably have to wait, I don't know, like a gazillion years, basically, right? Before it actually finishes printing the flag. And we could wait, I don't know, like really 100 years, and it still would like be printing out the rest of the flag. So yeah, what we have to do is we have to understand what is the program doing, and then we have to optimize it. So what we will do is we will start by opening the source code, which is this lib file, rs, and the other file was the main rs. Here we go. Do we need to patch the ROM? There are 2 ways to go about it. We will either have to patch the ROM, or better, either re-implement it in Python, or do something like that. I usually would go to like re-implement whatever you're reversing in Python, but it kind of depends on, especially like this is a, what was it, like if we do hexdump again, right? Hexdump hexdump, right? -c vmrom. It's 130, like 300 bytes. That's nothing. That's probably going to be like a few liner in Python. Okay, and this is the source code where some comments, the comments are interesting already. It's like, so if you don't know how to implement a virtual machine or how virtual machines work, then look up some of my archived live streams where I made some virtual machines. I think I made several live streams about that. And yeah, long story short is that it's a loop where you byte by byte, or rather instruction by instruction, execute some code, and you need a switch case, which is like if this is the instruction, then you need to do this, and if this is the instruction, you need to do that. So that's one thing. The other thing is that it usually has some environment or some context, and in our case, that's going to be this. By the way, looks interesting. It's going to be this. We have a file. We have registers, 256 registers. By the way, I don't know Rust, so I'm going to be guessing what's written here. But U32 means like unsigned integer, 32 bits. That's pretty clear. 256 of it. The stack is 64 kilobytes, and it's a pretty large stack. It's in that case, like because each element of a stack is actually made of a 32-bit element. Then we have some flag and SP, which is probably a stack pointer, right? So we have this, and then I have no idea what's the input data. Then we have some VM, whatever, step, and this is the switch case which I meant for the instruction. For example, if we have move const, then it for the registers, it uses reg as an index, I believe, and it puts the value, which is the second argument, to it here. So this is basically the assembly description which we get. And is there anything surprising here? No operation, move constant, move immediate value basically into a register, easy move one value from like one register to the other register, math operation, and it gets an operator. And then we have addition for 3, 4 is subtraction, then we have multiplication and division. Any other, I guess that means any other is unimplemented. Then for the stack, like pushing register to the stack, pushing a constant, like an immediate value to the stack. Jump const, I'm guessing this means like you know, unconditional jump. And it seems it's just like moving the file around. So we don't have a program counter or like instruction pointer. Instead, we are just moving the file around, which is fine. It's kind of slow, but it's fine. Then we have pop PC, which moves the file around. So this is return. This is basically return. Pop PC, I think I saw some actual real architectures where you don't do return, you do like pop PC. PC being program counter. Then we have test, which puts in the flag, I guess the flag we saw above the boolean, right? If the operand is 0, then it does this kind of comparison. Otherwise, it does this kind of comparison. Then jump conditional, and C is, I guess, the target. If not flag, oh, so this is interesting. The jump conditional is being done when the condition is not met, when the flag is set to false. This is, I would expect it the other way around. Call, which is, yeah, like call a function, and the pop PC is returned from a function, right? Then these were still, and this is pretty weird. And this one is, it puts in reg rv. What is reg rv? I don't know. Okay, maybe in this file. Ah, yeah, here we go. There are some constants. So reg rv, I guess rv is return value. That's just guessing, but I'm pretty sure that's going to be it. Register 0. Arg0, we put... So yeah, the arg0 is register 1, and arg1 is register 2, and the flag register, I guess, is this. Which means that I don't think this is the CTF flag, I think this is like the flag which we looked at. Or maybe, I don't know, we'll see. But yeah, so we know that register 0, 1, and 2 are like the calling convention, basically, of this architecture. We can also know that in this case there are no functions which take more than 2 arguments, which is pretty interesting. Okay, so in the return value register, so register 0, we put input data length. The input data was this weird array which we saw here. So let's go back to string length. Then character at, char at. We put from argument 1, the value which is in the register 1, or rather, yeah, that's register 1, we put in the register, return value register, we do an iterator of that, and we select the nth argument. So I guess this just selects like the nth argument from that array, and that's it. I have no idea what unwrap or means. We'll figure it out later if it's important at all. Then type register char. Okay, that's fine, whatever. But the actual registers are 32-bit, like we saw it here. Then we have print instruction, which does, wow, it does a lock. You have to do a lock on standard output before printing out. That's actually amazing. Because yeah, it's a problem in other languages, but you have to there are no locks, and there should be locks for standard output, because sometimes it gets really messy otherwise. And it writes out the. I'm guessing it writes out one character. That's how I read it. And then exit. Okay, cool. So this doesn't seem like a complicated architecture and a short program. This should be easy. What is this? For each step, we have some printing here. I'm going to uncomment this because the bug messages might be really helpful for us. I'm going to uncomment all of this, and then I'm going to rebuild it, like cargo build again, cargo right build. Okay, and now we can run it again, and let's see what happens. Yeah, except it's not this. Wait. If false, if true. Let's try it again. Okay, we have a lot of output. Okay, so we have the assembly instruction. This is, I guess, the PC, like the program counter. Then we have the value of the stack and the true. Okay, so what we want to do now is let's just dump it to a file. And this is going to go like for, forever, right? So I'm just going to wait, I don't know, 10 seconds maybe. So how's it going, folks? Okay, enough. There we go. And now we have this dump file, which will probably be really useful. I'm going to put it here. And now let's try to get all and every instruction like this. We are going to do cat, or rather, grep dump. Let's grep for, like, I guess sp equals. Okay, and now we have the instructions which are being executed, but it's like which instruction is executed followed by the next instruction which is executed. But what I want is I want to have basically an image of what is actually going to be executed. So to do that, I'm going to do a couple of things. First of all, I'm going to remove everything between one pipe to the other pipe. Yeah, okay, good. Sounds good. And now what I'm going to do is I'm going to do sort-u. Yeah, okay, cool. And now I'm going to call it prog.txt because that's our program. Cool, so we don't have to write a disassembler. It's pretty common that you have to write a disassembler in such challenges, but because this is beginner's quest, it's a pretty simple challenge, we don't have to write it. 10, it's here, we don't need these are redundant, and this is our program. Now, we know our program by looking at the hex dump, right? We know our program is like, this instruction is like 1 to 6. This a call, and the call is to 188. So what's 188 in hexadecimal? Wait, I already have a console somewhere here. Python hex 188. That's BC. I don't know, is this the BC? I'm guessing like this is like kind of the last instruction somewhere here. So like this is the Maybe there will be one more instruction, we'll figure it out. Okay, so what we know? We know that a call is a call. Wait, but yeah, this is decimal. Why is this decimal? I don't know Ruby enough to actually... Oh, just adding X should fix it, but yeah, like, whatever. So hex 00 BC, we jump here to 00 BC, then this is a jump conditional 48. I'm not looking at the code yet, I'm just like fixing this. So that's 0030, then 69, it's 45, 0045. 16, that's 0010, I do not need a calculator for that. 126, that's what, 7E, right? Yeah, 7E. Okay, then we have 94 here, and twice actually. 94, it's 5E, 005E. And here 005E as well. Call blah jump 303. 001F. 1 to F actually. Yeah, 1 to F. This was 005E, right? We already did it. Yeah. Here's 0010. And here's 188, but 00 BC. Okay, cool. So we know these are function calls, which means that this address is a function. So let's go to 00 BC here, and we know this is a function. Let's call it func 00 BC. Then we know that if we go to 5E here, we know this is another function, 005E. And it's pretty obvious also because this is a return, as I said. So this returns from a function, which means, yeah, this is like, it won't go to the next instruction, which means this is like a boundary between two functions, which means we have it right. Then call 10. 10 is here, so we know this is func 10. So we already see a recursive function, right? Yeah, this is a recursive function, which is going to be funny. This actually as well is also a recursive function. Okay. And then, do we have any other calls? No, this one jumps to 1F. We do not have 1F, but I'm just guessing this is exit. Like 1 to F exit. I'm going to assume this is exit. Okay, cool. So now we can start to reverse engineer it. Now, what I'm going to do is I'm going to be writing here on the side what I see in a pseudo language, right? So I see here, for example, but we move a constant to I, so register I. So let's call it Ri, or maybe just I, is equal 0. This is what we do here. We have a value of 0 and we move that 0 to register I. That's cool. Then we have a register which is \U1. I'm going to call it register, or maybe U1, just U1, yeah. Is equal to I, but we know that I is 0, so we know that's just... oh, I know, maybe that's the first register, and we already seen it here, right? Yeah. So first register, that's argument 0. So we know, let's call it argument 0 maybe. So arg0 is equal to I, which is 0, so we just put 0. And then we call here, like, yeah, we call fonts OOBC arg0. So we know we are just going with this function of 0, basically. Okay, let's continue. We are pushing something on the stack, we don't care. Then here to the register G, capital G, we move the arg0. So we put arg0 here. Let's maybe change like U everywhere. Sorry. \U1. Let's change it everywhere to arg0. And let's change 2. I expect, yeah, we have a 2. That's going to be arg1. And then we have this 0, and we know this is the return value register from where we seen it before, right? From here we have this register 0, that's the return value register. So let's just change that as well. So that's like red val. Let's call it red val. Okay, here we go. This should make it a little bit easier. Okay, here move constant I equals 0 again. Then test. We test if G is op1. What's op1? Test. This is not test, this is test. It was op1, right? Operator 1, yes. So we test if whatever like register on the left side is smaller or like lesser or equal. So we are testing flag is equal G, yeah, this is basically what we get. And when we jump here, we take the jump only if the flag is not true, which means that if G is greater or equal to 1, we take the jump to 30. To 0. Yeah, we see I is 0, so we can just write 0 here. So if J is greater or equal than 0, we jump to 30. No, it's not greater or equal. Here it's greater or equal, yeah. So here is just greater, yeah. Okay. We know that registers are unsigned, which means that if G has 0, then we don't jump, I guess. Okay, then we continue. This is 30, by the way. So yeah, the jump conditional 30. Did I mess something up here? Because why would we just jump here? Like we don't need to jump here, right? Did I mess it up? Let's try to do this. What's that? That's 1F. That's 48. No, that's 30. Like, why does it jump here? That's weird. Okay, well, I don't know, but maybe. So it doesn't matter, like, really what the test result is here. This is going to go here anyway. And here we put in I 256, then we test whether that's 0. Okay, so now flag is equal G I 256. If G is lesser than 256, then in that case, we jump to 45, only if G is, and we reverse the condition. 255. By the way, I have no idea what this code is doing, so like, we have to figure it out in a sec. Rather, I would not have an idea if I wouldn't solve this task before, but no spoilers yet. By the way, if you're wondering what kind of process I'm following, but if you go to Ginveil, how to start with reverse engineering, or you can just go to like Ginveil.live and look at the FAQ, then this process is described in this blog post. This is this process which I'm following. So if you're interested, take a look. Okay. Here, we move into redval, so returned value is going to be equal to G. We put G there. When we pop G, we don't care about that, and here we do return. So we are basically doing return G, right? We can remove this. Then we are going to put in I 256 again. Then we are going to do math operation number 4. We are going to register out is I, we can see it here. It's going to be G something something I. 4, that's subtraction. Okay. So G minus I, we know I is 256. And then we move into arg0, we move I, so the result of that. And we call 10. So we call func, we call itself as recursive, right? And we do return basically. So we do return, like here we have return, right? So we return this. Okay. So now we have this function translated into the pseudo language, and let's try to figure out what's going on here. We don't need this. We don't need this because we already have it in the jump. So this is kind of an op, right? Like regardless of whether we jump or we don't jump here, we don't need it. It's an op, right? We go to this instruction anyway. So this is not important anyway. Okay, now, if G is more than 256 or equal, then we go here and we subtract 256 from G, and we continue by putting the value into like another loop. So we continue subtracting 256 from this as long as G is more than 256. Otherwise, if it's not more than 256, we just return it. So yeah, this function, right? It's a really slow way to write return arg. Like, yeah, just like, or if it's simpler for you, is like return the remainder of dividing this function by 256, which is equivalent to return the bottom 8 bits of this value. So yeah, so already we know this whole code is identical to this one-liner in Python. Okay, we are moving forward. Yeah, Rabbit Rust, who cares? I don't need to learn Rust though. Okay, so let's go here. Now, what's going on here? I'm going to follow the same process. So in G we put arg0, then in I we put 2, and then we test op1. So I'm going to just write it here. We do a jump if G versus op1, and we do a reverse of op1, right? So op1 is this, which means we do a greater than I, and I is 2, so if 2, then we jump to 007E. Otherwise, we go here, and here we put 1 in I, and we put I in I wonder why we couldn't put like 1 directly in return value, but whatever. And then we just return, so we just return 1. Yeah, otherwise we return 1. Then we put 1 in I, and we do math operation number 4, which was subtraction, right? Yeah, that's subtraction. Here we go, so that's I equals G minus I, where I is 1, so we know, yeah. And then we call the same function, so func005e, and we call, well, G minus 1, right? And then we move this to x, so I'm just going to write x equals, yeah, like move x, the return value is here. And then what's going on here, we put 2 into I, it's the same code, right? It's the same code, it's just repeated, and we then put it into y, so, but the constant here changed, which means that's x func, yeah, G minus 2. And then we do operation number 3. What is that? That is addition. So we add x to y, we put it in I, and we return it. Okay. So we do return x plus y. So what do we have here? We have we get the argument, we check if it's smaller than 2, we return 1, otherwise we return a recursion of this. And yeah, we know what this is, right? Fibonacci recursive. Okay. Yeah. This is this. It's this. Like, yeah. So this function is just calculating Fibonacci for a given number. Okay. So then let's continue with the next function, and this is the last function, by the way, so we are pretty close. Okay, we put the argument 0 here. By the way, at the beginning, the argument 0 is 0 here, right? Then we put an argument 0, whatever is in B. What's in B? I don't know, so that must be 0 probably. Or do we... That's weird, because where are we using like register B? Only here and here, so I don't think it's I don't think it's really important because like I don't remember string length actually using any, let's see, it's not using any registers apart from return register. So we can ignore it. Now it's going to put here. In G it puts, which it overrides, like, so yeah, this isn't not important because it's being overwritten here. It puts the length of the array. So let's just type len here. When it does, no, it doesn't put it here. It checks it and then it does a jump. So the jump is in case, oh, yeah, so I'm sorry, this is important after all. So in case arg0 is 0, that's this, so we change it. More or equal to length, we jump to exit. We know that's exit, right? Okay, that looks like a standard iteration loop. Or rather, maybe a recursive iteration loop. But yeah, that doesn't matter. Okay, so in G we have length, then we have, okay, we call char at. And char at, I believe, takes one argument, yeah, only from argument 0 it's, or sorry, argument 1, only from argument 1. So argument 1 only from G. And the G is, no, it's not length, that's a mistake. So here we are doing basically, this H register is going to get char at G, and the G is arg0. So here we go. Arg0, by arg0 I mean arg0 of this function, so maybe, yeah, maybe let's call it the G. That might be better. When we push stuff on the stack, we don't care. And we do a mathematical operation by doing this. Yeah, this is a really simple assembly. So we put I, and then we store it in argument, and then we call the function Fibonacci. So we called the Fibonacci function from G plus 1, G being the argument, right? So that's 0 at the beginning. And then, what do we do here? We call it, here we get the red value. So I is going to be the G plus the Fibonacci, so the argument plus Fibonacci from G plus 1. And then we, what do we do here? No, let's reg out I, okay. And then we add H to it. What's H? I don't know what's H. Red val char at. Oh, so that's the character at. Okay, okay, cool. So this is the index and this is the character at. And then we do this, which means we do I is I and F, and then we print it. And I think this is enough to solve the task, so let's try it. I'm going to create go.py, and I'm going to basically implement this program, right, in Python, which is like, we need to copy this array first. Let's just call it array, okay. And now for I in, they were looping for the length of array, like, so length of array. We do k is equal math. Do we have a Fibonacci implementation? Python fib. I'm just going to randomly copy. Like a linear implementation of Fibonacci. That's a recursive one. I want a linear one. Come on. Wow, that's an overcomplicated as it gets. Python linear Fibonacci. Here we go. Okay, hello random website, please give me an implementation. No, this is a recursive one. You know what, I'm just going to copy like the sequence. factored. I don't want it factored, but I need length actually. Print length of array. How many Fibonacci numbers do I need? I'm just going to like this on array because I don't care. Okay, Python go. Okay, 63. So I need 63. Fibonacci 100 numbers. Here we go. What? Okay. 63. Does it start from 0? I don't know if we start from. Let's just go like this. Okay. Okay, perfect. Now we have Fibonacci. Okay, so now for I in range, what was it, 63, right? We do, where's my program? Here we go. We do this basically. So this is actually G. I'm not sure if we add this. We'll figure it out in a second. And H is R of I, and fib is actually G plus 1, this, and then we do this, and then we do print CHRI, and yeah, let's just go with this and see what happens. Syntax error, perfect, because it's Python 3. Array is not defined of I because it's G. Yep, and we got it. CTF, this is a very long flag and you might run out of juice while decoding it. Yeah, but it didn't. Yeah, just write your own Fibonacci. I could, but I'm lazy. It's like, yeah, on CTFs it's basically like the less you code and the more tools you use, the better. And you have to code a lot anyway. So that's basically it. Yeah, as you said, it wasn't really hard. Like, thankfully, we didn't have to write a disassembler. We just like had to uncomment this stuff, then do like convert the dump into a program, and then like just analyze it and write pseudocode, and that's it. Yeah. Okay. So yeah, and we but basically what we got at the end here, right? This is the whole program, right? The whole like 300 bytes were like written in 4 lines of Python plus these two. Okay, if you have any questions towards this task, please let me know. I'm going to take a look at the chat, but basically, yeah, as the self-destruct sequence starts, total chaos quickly erupts. Alarms go off and guards and other stuff start quickly running in panic around. Yeah, perfect. You manage to slip away in the mess and make it outside just as a huge explosion goes off. Kaboom! You made it. The enemies are beaten and you successfully stop their evil plan to destroy the world. We, by the way, have never learned what the mission was. Just saying. We, like, went to a random location on a ship and to a random island and we blew it off, but we still have no idea what was going on. But that's fine, that's fine. It's like, yeah, as long as there's action, right? Okay, let me take a look at the chat if there are any questions. Maya Bank says that they remember me from Sinful from Portugal. What was that, like 2 years ago, 3 years ago? That was good times, good times. I really enjoyed Sinful as well, and Portugal as well. Okay. So let's continue with the tasks which we missed. Can you give an example of a real-life scenario similar to this disassembly task? That's a good question. So this kind of stuff is basically what you do if you encounter a custom virtual machine which somebody implemented, and there are like quite a lot of virtual machines all around, right? So you might encounter it from time to time. Like like, for example, I don't know, like C++ exceptions and GCC use a virtual machine, like Flash is a virtual machine, Python is a virtual machine, PHP is also a virtual machine, and so on and so forth, right? And sometimes you might just stumble on like some custom implementation of a virtual machine, and you have to decode it because somebody figured about like, hey, why should I write the application logic in like C++ where I can just like make my own language for that? And that is a pretty good choice sometimes. So that's where like, and also if you encounter an undocumented architecture, you might have to do stuff like that. It gets a little bit more complicated though. And yeah, like, but that's for like, you know, like weird architectures, because like reverse engineering like this, that's like bread and butter if you play with reverse engineering at all, right? Okay, so which tasks have we not completed yet? We did not complete, what's the lowest task number? 4. Okay, let's go with 4. And that's a secret base location, and yeah, what do we have to do? Electronics Research Lab. Welcome back, Agent. It seems like you get a lead, but perhaps gives a clue where the next journey on your quest goes. Visit the lab and talk to Dr. Klosterman. He will know how to decrypt the device. Note, if you solved the challenge before but could not submit the flag, please try again, but okay, this has already been fixed for us. So, let's go with challenge number 4. Oh, I know this one. So we get 2 files. This is the first file, and the second file is a, let me maybe show you here, /la, there's like Pico UF2. These are like files from, if you start Googling for this is a file which is for like Raspberry Pi Zero, the new ones. And if you compile it and you attach a logic analyzer, then you would get the flag at the end. And this is also like the UF2 file. I believe this is the image. But we also get the source code, so we don't need to do that. And what we have here is we are doing like a set mask and a clear mask. So GPIO, these are like ports, like pins, and you set either like high state or low state, like 0 or like 3.3 volts on them, right? And this is just a mask, like a bit mask, saying like which port should have set it to high and which should be not touched, not changed. And clear means like which ports should have the bit changed to 0. So yeah, set basically means whatever is the condition of the given pin, please rise it high. And clear mask is whatever is the condition of a pin, please take it low. Please like change it to 0. And this is a bit mask, meaning that there are 8 bits in a byte, and 1 bit is 1 pin. That's it, like end of magic. So what we have to do is we have to basically at each sleep, we have to take a look what's the state of the pins, of the ports. And at the beginning it basically like changes everything to 0, and it sets all the pin to output. Okay, how do we solve this kind of task? We copy paste this to Python because obviously. Okay, so we copy paste it to Python. Good. Now we do GPIO, like set it to 0. Then we implement the function. So GPIO, because this is actually proper Python syntax as well. So that's good. Okay. Mask, this is the mask, we use the global GPIO and we need to clear it. So GPIO, and how do we clear a mask? We basically do this with a negative mask. Yeah, we do an AND with a negative mask, that's clearing. And if we want to set it, set mask, that's even easier because we just OR it. So global GPIO, and we just do GPIO, we just OR it. Again, know your bitwise operations. This is the most important thing. And then on sleep, as whatever the argument is, we don't care about it. We can do print chr GPIO, and then, and yeah, we don't end the line. Python 3 go py. We get the flag. That's it. Thank you very much. So yeah, like this wasn't really a hard task. If you played with Arduinos or like Raspberry Pi or whatever and you played with pins, this is really intuitive for you and you should be able to easily solve it. If you have never done this, you might have spent more time on this, because I never programmed on Raspberry Pi Zero, but just looking like GPIO, set, mask, it's obvious for me what it does. If you never played with it, it's like with a video challenge, like you might not know this. And this is where kind of experience comes into play. So if you go and start reading the documentation for this, then you'd be able to solve this challenge. Are there any questions for this challenge, by the way? That was 4. Here we go. Yeah. Okay, I see. I have no idea what you just did. Can you elaborate what GPIO does? So GPIO is general input-output pins. It's like, let me maybe get a Raspberry or something. Okay. Oh, and this is even a Raspberry Pi Zero. I didn't lie, but I didn't program on them. I really didn't. But I have a couple of them. They're waiting for better times. So, like, this is the Raspberry Pi, right? And this is the main CPU, and then these are the pins, right? So, some pins are like general purpose I/O, meaning, like, for example, this pin here, for example, this pin here, right, is like, let's say that's that pin number 0. If you set it high, then you will get a voltage on this, like for example 3.3 volts. So again, if we go look at the challenge, yeah, if you set it, and this is, as I said, like pin number 0, which means if we change it to binary, let's do binary. Yeah, if we do 1 here, then this pin would be set to high, to 3.3 voltage. And if we would do, then after doing that, if we would do here clear mask on the same pin, we are selecting the pins here. This is selecting the pins, and we are selecting the same pin. It would bring it to 0 again. So we had 3.3 volts, and now it's 0 volts. And if we would, and then there's a sleep, which means like, yeah, we committed to this value, and now if you connected a logic analyzer to it, or like an oscilloscope or whatever, you can read that value from it. You can see 3.3. And if you connect, like, there are 8 bits, right? So like 8 pins. I'm not sure which pins, but let's just go with like first 8. Like the flag would be outputted here. But if you would connect a logic analyzer to it, and it would draw the state of the pin, high, low, high, low, high, low. It would basically, you could just like decode the ASCII value of a flag from there. And what I did is I did basically that, but without playing at all with electronics, and instead I just like implemented a fake port. Like these are like 8 pins, 8 bits, 8 pins, and I like this basically is like turn off selected pins, as in like bring them to 0 volts, and this is turn on or set selected pins and bring them to, in this case, like I think it's 3.3 volts. It might be like some other voltage, but I'm just going to go with it. So I know the values are committed, and now I can just read from it. This might have not worked if this and this. This might have not worked if the order of the bits would be different. But if it would be different, then I would do something about it. But it wasn't different. Like it was like it was, and we got the flag immediately. Yeah, sorry. Again, like clearing is just like turn off selected pins, and setting is just turning on selected pins. And that's it. And I'm just like doing this by emulating a fake port. This is easier to understand if you played with any electronics and coding on like Arduino or like you know, some Atmega microcontrollers or whatnot. Then it would be way easier to understand. But at the end of the day, yeah, that's that's the gist of it. You didn't really have to really play with it. What you need to do, like with hardware, what you need to do is understand how the bitwise operations work here. That's it. Okay. Okay, so there are some questions. What is your experience with pandas? I have no idea what pandas is. I'm sorry. What's your opinion on VS Code versus Sublime 4? I never used VS Code, so no idea. I'm not really useful. I'm sorry. Now with VSL2, do you have any plan for like a different setup? Go to genvay.live/FAQ versa rubber genvay live and then click FAQ versa and answer for that. But basically, I don't plan to change any of my setup. Okay, there we go. Next challenge, 6. Yeah, we go from 4 to 6. Okay, yeah, this is a little bit guessy challenge. It's not bad, but it's a little bit guessy. So I'm going to solve it rather quickly because I know how to solve it. But yeah, like when I first look at the challenge, right, I saw this and I was, you basically get two files before I get ahead of myself. One file is like, I made a super secret encoder. I remember using a weird base much higher than base 64, a language named after a painter. Like if you played with any esoteric programming languages, you know this is going to be Piet. The language which is the opposite of good, you know this is going to be PHP. No, actually it's evil, but it should be PHP. I don't get this one. Well, something with Nyan Cat, maybe? A rainbow cat, something with Nyan Cat? I have no idea. A language which is too vulgar to write here. My guess, brainfuck. Might be something else. Might be PHP again, for example, right? A language which ends in ARI, no idea. And I also use gzip and zlib to compress stuff. That's fine. That's fine with me. Cool. So now this is the file which we get. And honestly, when I first saw the challenge, I had no idea what I'm looking at because I looked at the hex editor. And then I looked at it and I like, hey, you know what? These values are actually correct UTF-8. And which means that like the moment I put it in Sublime, I was like, yeah, obviously. Now, if you see this and you have no idea what this means, it means you can't read Chinese. But no, that's not true. If you watched my Twitter live stream, you remember me using an encoder which was putting multiple characters into one Unicode code point, because the length calculation on Twitter, which is a code golfing for JavaScript graphical effects, by the way, website, it's absolutely amazing. You should check it out. It's twitter.org if I remember correctly. Yeah, so because they were using like the length was limited by Unicode code points and not bytes, and you can have like a code point which is multiple bytes, which means you can probably squeeze quite a lot of information into one code point. I made an encoder which worked basically like this. Also, remember the challenge 17? I also, in that challenge, specifically limit the number of code points and not the number of bytes. So I know some people found it already on Beginner's Quest while solving the challenge. Okay, so going back here, there are encoders, a lot of encoders which do that. So we are going to have to find an encoder which does that. And they do mention, like the author mentions, base 64, right? So if we do, or rather much higher than base 64, so we look for like base, Unicode, blah, blah, blah. Encoder maybe, and yeah, we find this, for example. So we have this encoder base 5536. Then we have base 248, we have this base, and this base, like quite a lot of different bases, right? And this is like all of these encoders are basically putting multiple bits into one Unicode code point, because Unicode code points can occupy multiple bytes. So it's kind of cheating, but that's fine. Now, part of this challenge is actually finding, I mentioned it's a little bit guessy. right? It's a little bit guessing. So it's finding which of these bases is actually the correct one. And because I solved this challenge and I don't want to drag the stream forever, I know this is going to be this one, and I know that we can find like online the coder for it. And it's, yeah, I think it's this one. Is it this one? String to no. At least I think it's this one. It might be this one or it might be the other one. Well, we'll see. Wait. Oh, here we go. No, sorry, it wasn't this one. It was the other one. It was... yeah, it was this one, I believe. Yeah, okay. Decoder online. Okay. Yeah, it's this one. So what I'm going to do is I'm going to grab this, I'm going to copy paste it here, and I'm going to click decode, and what we get is we get a hex string, which kinda already tells us that, yeah, this is the correct way to go about it. So I'm going to copy it, and that's step one. If you basically test all the decoders you find, then you'd find the proper one. So that's actually it. Okay, so now we get hex, and I named the file step 1. It's actually, I guess, step 2, but whatever. I'm going to close this one, and I need to run now my Linux console. Here we go. Okay, I can close this decoder. It's betterconverter.com. Sounds like a fun website. Okay. Cool. So now what we need to do is we need to, we have this hex, right? Like step 1 hex. And we have to change it into binary format. So you can do that with xxd -r-p. We do step 1 here, and we get step 2 to binary -r-p. Sorry, here we go. Okay, and then it's a standard tool. You should have it installed if you have Linux. Then we check what kind of file is this, and that's actually a JPEG image. Perfect. So let's take a look at this JPEG image. I'm going to change the extension, actually copy it to JPEG, and it looks like this. Do you know what this is? This is a Piet painting. So yeah, it's like, as I said, like, yeah, Piet, absolutely. But this is an actual Piet painting. This is not a program encoded in Piet. So maybe there's something else there, and what you should always do is you should look at the file in like some viewer or a hex editor even, right? Like this one. And we can see here, like, what is this? This is not standard JPEG data. Maybe this is metadata. So I'm going to use the EXIF tool, or like, yeah, let's say EXIF tool. And I'm going to call it on this JPEG, and I get that the author, the artist rather, is this thing. I think that's step 3 actually, so I'm going to do step 3, like call it as step 3. And now I'm going to remove everything apart from this. Now, what is this? No idea, but we still have this encodings files, which says that tells us like that it might be like something related to Nyan cat, something related to like opposite of good, right? So we go to ezolang.org, was it? Yeah, the Wikipedia for esoteric languages, and we can grab a language list. And we did mention evil here. Let's see how evil looks like. Maybe that's evil. Evil is hey, this looks like basically what we are seeing, right? So yeah, we need to probably run our evil program, or we need to implement it. We are not going to implement it, obviously. We are going to find an implementation because, again, CTFs, right? You try to implement the least possible amount of code. Okay, there's an... Okay, perfect. Evil language interpreter. This is going to be dead link. Well, yeah, it is a dead link. Let's take a look here. There's a Java evil interpreter, and which like, yeah, but actually like sounds good. Java is evil, so evil is evil. Let's just copy paste this interpreter, call it evil Java. Okay, here we go. I copy pasted it. Now we need to compile it. Java C evil Java. Java evil. And it does nothing. Why does it do nothing? Because it probably expects a parameter. Main. Yeah, it expects a parameter. So we give it step3 txt. Okay. And it actually outputs something. So it executed the program and it outputted something. So I'm going to call it step4.txt. Then we don't need it anymore. And what we don't need this either. What we need to do here is we need to again like do xxd-r-p step4.txt and we get step4 bin or step5 bin. Let's go step5 bin. Let's see what kind of a thing is this. It's a zlib compressed data. So we do zlib rubber deflate zlib flate. Okay, zlib flate. Uncompress, we give it step5 bin and we put it in step6.bin. 6 I said. Then let's see what step6 is. That's a gzip. So g unzip step6 bin. Unknown suffix, so let's just copy it. Step6 bin to step, rather let's move it to step6 bin gz. Gunzip. I'm sorry, again unzip. Here we go, step6. Okay. Now we check step6 bin, and it's a netpbm image data. Netpbm is a pretty interesting format. It looks like this, where the first line is actually ASCII, and it tells you the size. And then there is the, like, it's followed by just the data, like RGB data. So if we look at it, we can actually see it. I'm going to make a copy with pbm, was it? I'm going to call it png because I know IrfanView is just going to change the extension. Okay, and we get this chart kinda weird thing, right? And this is Piet. Yeah, so this is Piet. The language. We can probably go to Ezolang here, Piet. Here we go. It's one of the most known esoteric languages, that's why I know about it. And it doesn't have to look like this, it can look like the one we see. So, we need to run it in that case. Okay, let's find an interpreter in that case. Okay, here, can we run it online somehow? It's an interpreter. Oh, look, it takes a pic map, that's good. What's going on here? It's a screenshot, okay. Can I just download it? Yeah, I can download it here. Okay. Okay, I unpacked it. So we go to npet. And we can, I guess we can, there is this like 6 ppm, this is our pet file. We go here, what do we have to do? We have to configure it, do we have to, can we just make it? It's running configure anyway, well. Alright. Okay, we don't have GD. GD, what's the GD? I have no idea what's the GD. Apt file search gd.h. So that's not how you. Okay, grep gd. Okay, here libgd. Perfect. So let's just. I'm going to quickly install it. Sudo apt get install. Here we go. Now password typing. Okay, there we go. Is there an, like an... You say on the chat that there's an online website for npet. Get online interpret. Here we go. Okay, there's this one. I tried this one, it's just going to crash. Is there another one? Oh, that's one. That one is a nice one. We can try it. I'm going to choose the file, but off screen just in case. Okay, let's go back here. I am not a robot, last I checked. A fire hydrant. Let's play the game. Is next like, you know, Sarah O'Connor? No, perfect. Okay, update and execute. Upload and execute. Okay, it's complaining, but it gave us something. So I'm going to copy paste this long hexadecimal looking string, and I'm going to call it step. Thank you very much, Danilo, for mentioning it, but kind of saved us some time. Because I guess we don't have to compile it after all. So we have step 7, it's again... By the way, these like 7, 8, 9c, you can see already that this is going to be zlib again. If you played with zlib and you know how the header works, you know that, yeah, you see 7, 8 something at the beginning, that's probably going to be zlib. So, we are back here, we do xxd -r-p, step 7, txt, step 8, bin. And file step 8 bin is zlib, no surprise. Zlib, flate, uncompress, was it? Yeah. Step 8 bin, step 9 bin, because I have no idea what we are going to get. File step 9 bin, ASCII text. Okay, let's take a look. Oh, hello there. Nya. So I guess we are getting to the nyancat version. Okay, so this was evil, we don't need evil, we don't need piet. What we need is nyancat. How many nyancat? There is nya. Oh, this looks pretty similar because it's a tilde at the end, right? A tilde. Yeah, this is it. So how does it work? N decrements an integer, y increments an integer, and I puts a... Okay, so this is, I guess, a language which can only write... yeah. It's a language which can only write out things, and it cannot do... It's not really Turing complete. I'm not going to, like, download any interpreters for it, because it's actually just... It's going to be way easier than that. I'm just going to open it with open... what's it called? Step 9 bin. Step 9 bin. Okay, equals, we read it, we split lines to get every line from the file in an array. And now what we do is we do for ln in k, we do print chr ln length of the line. I'm going to do some modifications here in a sec. Okay. So here we are starting with n, and n is decrement integer. It was 0 at the beginning, now it's -1. So we already have to add something to this. And then so it's -1 now, and then these ones are not doing anything. So I'm pretty sure we are going to have to add, is it 2 for this to make sense? Let's see. Python 3 go. That doesn't look right. 4, 3. Maybe subtract 2, 3, 4. This looks okay. 4. Why 4? Because this is the length. But yeah, but I have to subtract these two because they don't matter. That's -2. -3, but then n does another -1. So that's -3, -1, that makes sense, so that's -4. And this is a number. Okay. So this is a number, and this also like our step 10 txt. Actually, I'm going to put it in Python because it's a large number. So view or drop. Okay. And first thing I'm going to do is I'm going to print it in hex, because why not? Python step 10 py. Right. Okay. It doesn't look too interesting on hex, honestly. Actually, also use Python 3. Yeah. If you're wondering, like, how can I save, like, quickly tell that it's Python 2 and not Python 3 is because this L at the end when putting out hexadecimal. Because, like, the numbers work a little bit different. In Python 2, you have, like, a long number and an integer, like int and long, and in Python 3 you have only int, which behaves as a long, basically, so from Python 2. So this, like, there is no notion of this L anymore. Okay, and now we are going to go back here to the encodings, and we are at this point. A language that ends in ARI. So let's take a look how many languages end in ARI. There's rotary, temporary, tupelary, unary, and so on. There are 15 languages, and there's actually one more which is not on the page. And again, I'm going to save you some time. We are not going to go through all of them. Some of them we can, like, say they don't make sense. Binary FAQ might make sense, but it's actually not binary FAQ we are looking for. It's actually not here. It's actually called unary. And there's also another one which is identical to this one. But let's go with unary because it doesn't matter at the end of the day. How did you know that the first image, like this one, was not meant to be executed in Piet? Because this is an actual painting. This is an actual Piet painting, and which means, yeah, it's not encoded data. Like, if you Google, like, Piet paintings, and you go to images, it's, which one is it? Is it this one? Not this one. Yeah, I'm pretty sure we could find it, though. Because it is a Piet painting. It's an actual painting, not a... this one? Yeah, it's this one. Yeah, so it's... Yeah. I know it doesn't encode any data because it's an actual painting, right? Made by the artist before they... like, when they were still painting. Okay, so let's go back to the unary. And it's an esoteric programming language, which basically isn't really a programming language at all. It's just like brainfuck encoded in binary. So what it does is you change this character into these 3 bits, and this character into these 3 bits, and so on and so forth, and then you add an extra 1 in front. So what we have to do is we have to basically do it like this. We have to do print this in binary first. Okay, and now I'm going to copy it, I'm omitting the first one. Okay, and we get, this is not important anymore. We get this. And I'm going to actually use it as a string, because why not? And now I'm going to use this translation table, which I get from Wikipedia, or rather not Wikipedia, esolangs.org. And what I'm going to do is I'm going to do this. For this string, we want to get this character. Yeah. And now I is equal to 0. And this is going to be the output. Or rather, no, maybe no. While... actually, what's the size of it? It's 1443 characters. So for I in range 1443, from 0 to this, stepping by 3, we do print translate, this is my translation array, from B, from I to I plus 3. And then end, yeah, this step 10 to I. And we get this thing which looks like brainfuck. So now we find brainfuck interpreter online. For example, this one, maybe this one. Oh, here we go. We execute it, and we get the flag. Please no more. Yeah. So this is a pretty cool challenge, but for Anary, for example, it was pretty hard to find. So I think that the hints for Anary should be a little bit stronger. The same with the hint for this one. The rest were pretty fine. Yeah, and I guess we've seen quite a lot of esoteric languages as well. If you never played with esoteric languages, they're made for fun, strictly for fun, for programming fun. So if you never played with them, check them out. Brainfuck, I guess, is a classic. Everyone must know Brainfuck. And it's also the language which I recommend for learning how to implement a virtual machine, because implementing a virtual machine for Brainfuck is trivial, like an interpreter, right? Okay, let's see how many challenges do we have left. So that was 6, now let's go with 7. ReadySetAction, crypto. Apparently this script was used to encrypt super secret messages. Maybe there is something interesting here. Note this challenge was previously broken. Okay, but it's probably not. Also, ReadySetAction, RSA. Nice. I love the wordplay here. I never seen this wordplay before. Good one. Okay, so we get this challenge. Here we go. Do I have, by the way, all the other... No, obviously. Let's clean up. Okay. So we get this challenge. Okay, so yeah. This looks like RSA. And this challenge is pretty easy if you know how RSA works. If you don't know how RSA works, this challenge is not going to be easy. This is like they create a key. This is creating a key. And they create a public key for RSA. Like they get 2 primes, and then they create a public key for that. And then they convert the flag into a number. Like you can, like convert any text to number just by concatenating everything and then like saying, hey, this is a number in base 256, and that's how you get this number. And then they encrypt it. RSA encryption is exactly this. They take the number to the power of e. In this case, e is 3, and this is important. So they cube it, and then and this is done in modulo n. And then they print c and n, and we get both c and n. So if we go to Wikipedia for RSA crypto system, and we go to attacks against plain RSA, the very first one is when encrypting with low encryption exponent, and like E3, this is exactly our case, and small values of m. The result of m is strictly less than modulus n, and by taking the f's, which is like cube root of ciphertext over integers, we get the message. And this is exactly what we have to do here. We basically have to do we have to take an integer cube root of this. Or is it this? Yeah, this, or rather, it's like this. The decrypted message, right? Because we encrypt it here, right? So what we do here actually is we do like the ciphertext is message to the power of 3, but modulo n. And what we can do now is we can do cube root, like not square root but cube root, right, of the cipher message. But this is done modulo n, which means that some n's might have been subtracted from it. So we will have to do a guess, basically guess what is the amount of k. It will be a small number. But we have to multiply like and add n to it, so that the cube root of actually this gives us the value. This is again something, if you played with modular arithmetic, then this is obvious. If you haven't played with modular arithmetic, I don't think I can explain it really easily, really fast. So yeah, but let's just do it. Okay, Python cube root integer. I need a function for integers, specifically for integers. Okay. Yeah. Okay, and fruit. This is a nice function from RIP tutorial. So I'm going to grab it. I'm going to do... Okay, I'm going to copy paste this function. And now I'm going to do... I need these two numbers. Dan says GMPY 2 works, so I'm pretty sure I don't have it installed right now. C equals N equals, and as I said, for like K in range. Yeah, for K in range of, I don't know, 5,000, I don't know, I have no idea. We do a cube root, so like N fruit. Oh, it's doing... Oh, it's okay. No, that's fine. That's fine. Of the ciphertext, the third one, but ciphertext plus k times n. Yeah, and we get the result of it. And now we need to convert the result into data. And to do that, we need to do like something like this, like m equals. Like from the number back to data. This is a hack what I'm going to do, but whatever. So we get a hex value of the number, then we remove the OX at the beginning, and then we do like bytes from hex. And now we need to turn it like reverse it, and that's it. And now if BCTF in M, we know we finished. So we're going to print it, print M, and break. Okay. Actually, let's just run it on Windows, it will be a little bit faster. Python, that's Python 3 by the way, go py. Non-hexadecimal at position. Okay, this means that the number has a... That's easy to fix. If length of L is odd, like divided by 2 is odd, then we need to actually add 0 at the beginning. Okay, that's weird. Non-hexadecimal number found at position 171. What the hell? Okay. Oh, it's 01. Sorry. Yeah. Okay, and it's running now. Yeah, I see you found it on the chat already. And it didn't find anything. Let's just make it a little bit larger. I'm a little bit unsure about this one though. Maybe they didn't reverse it. Now that I'm going to break it, maybe they didn't reverse it. That would be pretty weird because you usually reverse it. Oh, they didn't reverse it. Okay, now I'm a little bit surprised. Usually you reverse it. For reasons, but yeah. Okay, CTF, easy RSA is, yeah. So this is a pretty decent crypto challenge actually. It's like, I'm not sure a beginner could, without knowing RSA or modular arithmetic, could solve it. So I would say it's a moderate challenge. It's not an easy challenge by any means. So if you failed at this challenge, don't feel bad. I do encourage to learn RSA, though it's pretty easy. As far as crypto goes, RSA is pretty easy to understand. Okay, that means we have, what, 3 tasks left, I think? Okay, so task number 9. Let me just... Good. Why do you have to reverse? Yeah, you don't have to reverse, but Again, it's pretty typical in RSA, but you do reverse it. So that's where my experience made it harder for me. Oh, this is a funny one. Okay, Konski-Hiakawa law of droids, reversing. In this challenge, you have to find the flag using memory forensics. Good luck. Note, surround the flag with CTF to, yeah. And note, API level 25 is what you're looking for. I have absolutely no idea what this means. I'm going to show you how to solve this challenge, and you are going to be like what happened in a few seconds. So first of all, you download IDA. Okay, what you got? What you got is you got 4 files. You got APK, which I'm not going to touch. BZ image, which is a kernel image for Linux, probably Android one because APK. The ELF, which is an uncompressed version of this, and an IDA profile. So I'm going to run IDA3. Actually, that's actually IDA3 file, I think. So I'm going to run IDA3, which I downloaded today. And yeah, go work on my own. Here we go. And I'm going to open this file. Okay. And now I'm going to press F5. After this file loaded, I'm in syswrite. And then there is this like weird thing here. If there is research CTF in whatever argument syswrite got, and there is this gctf key thingy, then put this inside. So what I'm going to do is I'm going to grab this, do CTF, put this here, and challenge solved. Yeah. In all honesty, I don't know what was the intention behind this challenge. I think you maybe had to dig a little bit deeper into what the APK does. I did look later at the APK, and you basically have to look at this kernel file. But because IDA opens exactly in the right spot, and you see this weird file which is exchanging like this gctf key thingy, yeah, that's it. We're done with this task. So maybe that was the idea. I honestly don't know. That was how I would solve it. Okay, task number 11. Okay, pwn-notebook. Please help me restore my deleted node. Okay, let's download it, and there's a link. But it's again a netcat link. It's a broken link, so let's do this. I do believe that was, sorry, that was 11. Yeah, that's 11. Okay, so what we get here is we get a notepad file, which is actually... Okay, here we go. Which is actually an ELF binary. But to see it, we can just run it. So I'm going to create a notes file. I'm going to copy paste that link. Yeah, and I'm going to just open it in netcat. Yeah, we already are done with the challenge. Okay, proof of work disabled. This is your confidential notebook. This should get you through the next mission. Yeah, the description said that we have to basically recover one of the deleted nodes. So yeah, what can we do here? We can list the nodes, so this is it. We can print out a node. Can we print out, for example, the deleted one, which is 3? No, because it's deleted, so it says deleted. Then we can make a draft node. We can add a node to the notebook. Like, for example, let's add a node ASDF, and then list it. And as you can see, 3 is no longer deleted, which means it's got reused. And then we do, like, we can print it, right? So 2, 3, here we go. And it's ASDF. And then we can delete the node as well. So we can like do 5, and we can delete node number 3, for example. And then we see it's deleted. So this is this kind of application, right? And we have to, yeah, I think IDA3 comes with a decompiler. I think it's a little bit limited, but it comes with a decompiler, yeah. Okay. Yeah, and now we have like the main file, which isn't, I think, sorry, I'm going to reopen it in IDA3 actually, because IDA3 is a little bit better than my old IDA, which I have from some time ago. So I'm going to do this, go work on my own, here we go, and I'm going to do this. I think I should buy the new IDA as well, it looks really cool. Okay. Yeah, so yeah, it's basically like what you would expect, right? There's a scanf, and then it jumps into a jump table. So if we switch to this assembly view, we will see here that we jump into list function, print node, draft, add node, and so on and so forth. So this stream is already going for 4 hours, so I'm not going to analyze everything. I'm going to go straight to the vulnerability. It takes some time to find it. I first looked at the list, and if we look at the list, there is like nothing really interesting here. So then I looked at the print node, and the print node is, the interesting thing here is that I can input here, like they get like, which node would you like to print? And they get an integer, but then they do a signed comparison, which means I can do like 1, 2, 3, 4, like 1 minus something, like a negative number, right? If this would be a 32-bit application, this would be the solution. We wouldn't have to do anything more, this would be the solution done. But it's a 64-bit application, and we cannot like overflow the pointer enough to do that. So that's not it. Okay, draft node. This is actually where the vulnerability is. If we look at the draft node, we go to cat say, or rather, well, there are several ways to trigger the vulnerability. We can also add a node and then print it, but I'm going to use the draft node. And it calls like, it gets a string from us, a string up to 511 bytes using scanf, and then it goes with cat say, calls this cat say function, which does print line, it does prepare, and then it does print line. And the print line does this. If you are like intermediate with low-level exploitation, or rather like late beginner in low-level exploitation, you know what this is. This is a format bug, which means that usually in printf, you have the formats here, like %s and so on and so forth, right? But here, somebody forgot the %s, which means that our controlled string can actually be the format of printf. And this is something we are going to use. So I'm going to disconnect and I'm going to reconnect. And I'm going to draft a node which says %x. And as you can see, instead of x, it printed a number which it found either in the registers or in the stack. So this is actually enough to solve this challenge, because we know that by analyzing this further, we would learn that the deleted nodes are still in memory. Let's just go to the delete function for a second. Delete node. F5. Yeah, because when deleting something, and this is by the way on the stack, it just sets a flag that it has been deleted, but it doesn't overwrite the string, which means it's still in memory and it's still in the stack. And what we can do is we can put enough x's, %x, 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 to start writing out the memory of that part. But yeah, and we can actually do one more thing. We do not have to actually write a lot of x's. We can use this same thing over and over again. So we can do, for example, $1x, or rather LLX to display the full 64-bit value. This means show us the first argument on the stack. If we would do 2 here, $2 LLX, that would mean show us the second argument, and then the third, and so on. So we can just be increasing this and until we find the flag. So that's what we're going to do. And to do that, I'm going to use the my pwn tool. Like other, not pwn tools. I have my own library, as you know, but you should use pwn tools, totally. This is pretty old, but it's fine. Okay, so where do we connect? That's the first question. We connect to this address and this, or rather this host and this port. Here we go. And now we need to send. What do we need to send? We need to send 3. Then a new line. And then we need to send this quote thingy. So let's say that I'm going for I in range. I don't know what range, so I'm going to just go with keep increasing I while true. I'm going to send this, and then we are going to send this is Python 2, by the way, so percentage plus string I plus $LLX, and we start with 1 and a new line. Okay, and now we actually need to get like receive everything, receive until we get this, but with a new line at the beginning, and then we need to receive until this and a new line. So let's just call it K, and we do not care about the 3 last characters, so we do this. And this is what we are going to find now. So I'm going to do a break here just to test it. I'm going to remove this. And I'm going to print K, so we see what we get and whether this is working. And this is Python 2, as I said. So Python pound base. Okay, did I do something wrong? And this actually looks fine, but I think it's waiting for something. Is it waiting for this? No, it got this. It's waiting for this. There is no space here, the space is here. That was my typo, I apologize for that. Okay, and yeah, and we correctly received the number. We are basically like doing this, and we are cutting out the number from here. This is all we are doing. So now I convert this number to, it's a hexadecimal number, so I like cast it to a number, I guess. And then I read it as big endian. How do I read it? As little endian. I encode it as little endian. And for encoding, I actually already have functions for that using struct pack. So I'm going to do EQ and the number. And this is going to give me bytes. Now I'm going to print this bytes as hexadecimal. I have already hex print, so I'm going to do hex print B. Or rather, I need to do CHRX for X and B. Okay, I need to a list of it actually. Okay, and an integer is no, that's CHR, or sorry, the other way, the opposite. Okay, yeah, and now it prints the leaked bytes. These are the leaked bytes. And now I can remove the break, and we can run it, and we can wait until we find the flag, but we need to increment I, which I always forget. Like, really, I always forget it. Here we go. I did something wrong. Oh, wait. Because the cat... I'm here hunting for this. And it should be fine, actually. Because the cat doesn't have this anymore else in the ASCII art. What did I stumble on? Print K. Let's just maybe do it. Okay, let's do it like this. Didn't I remove it? I'm going A here. And I should have removed this. That's pretty weird. Can I just do like... Wait, how does the cat look like again? No. Okay, I need to see what I'm actually like dumping here. Okay, this is A, and then I get this. Why was it not removed? I didn't get it. What does it get more? Well, okay, whatever. I'm going to split it by space in that case. Yeah, that works fine. I don't know, maybe it's the late hour or something. Okay, and now it's dumping memory, so we just wait until we get the flag. Shipping something something, that didn't look like a flag. PSA, public service announcement, not a flag. Note to staff, not a flag. Flag. Here we go. Reminder, CTF format string for the win. And we have it. Now let's just put it together. Okay, CTF. And this is our flag. So yeah, we basically just dumped the memory, and that's about it. Okay, then we have challenge number 14. Is this the last challenge? There might be one more challenge, I think. Okay, let's see. It's a... Okay, it's are there any questions to this? Yeah. Okay. Let me close everything. I don't think there are any questions. If there are any questions, just please write on the chat. Or in the comments if you are watching this after some time, I guess. Okay, now we have a website, and we, if you'd like to return to this code, press here. Okay. So this, well, quotedb, this is probably SQL injection just by the name, right? So let's try, like, I put this here, and let's see if it fails. It fails, which is great. Let me change, like, I just added a single quote here, but I'm going to do one more thing. I'm going to put, like, a square bracket here, and I'm going to do 4, and now I'm going to do select 4. And yeah, it still works. It still works, meaning this is an SQL injection. So if this is an SQL injection, you know, like on a CTF you can be lazy. And this looks like a run-of-the-mill typical garden variety SQL injection, which means I'm going to use SQL map. I don't commonly use SQL map on CTFs because usually the CTFs you play are the SQL injection is like so tricky to get that SQL map will just fail. But in this case, like SQL map -u, and let's just see if it works. Yeah. Okay. I actually already did go through this website with SQL map. That's why it's finished so fast. So now let's go dump the databases. Oh, hello. And databases, there are these databases. There is the quotedb database, which is the most interesting one, and all the other ones look like system databases, so we are going to ignore them apart from this quotedb database. So quotedb. By the way, SQL map is an SQL exploitation tool, which is pretty useful on pen testing. So you should learn it. First you should learn SQL injection by hand, including blind SQL injection, and then you should learn how to use this tool, because then you will understand it, what it's doing. Okay, so we have quotes, and now we need tables. And the tables are flag or quotes. So let's select the table for flag. And we've selected it, now we just need to dump it. Okay, and that's it. CTF little bobby tables, what we call them. That's it. If you know how to use this tool, if you know how SQL injection works, super easy task and super fast to do. And 16th, this is the last task. So, okay, so this is about a Discord bot. Hash-meee. I heard bot, the resident Discord bot, is experimenting with hashing. He specifically wants to see 2 different strings, both starting with GCTF, but have the same MD5 hash. He will reward this with a flag. You can find it on Discord, and this is the link to the Google CTF Discord. To solve this, DM the bot and type !Hash-meee and the strings encoded in hexadecimal. Okay, that's fine. So how do you find collisions for like with the same prefix, right? It has to have the same prefix. And this is called a chosen prefix collision attack. So MD5 chosen prefix collision, we look for this, and we look for like some applications, some tools for it. And hash clash, yeah, we look for hash clash, for example. And let's just write here hash clash. But I'm looking for the tool. Here we go, fast collision, and we can, if we scroll down here, we can download it. This is the software. So yeah, again, like CTF, unless this is a hard CTF, you do not want to be writing crypto tools, you want to download crypto tools. So I'm just going to download it. It's called fast call, fast collision, and this is the task number 16. Here we go. So now when we run it, we get this like fast call file, and we can submit a prefix using this prefix file. But I guess the easiest way for me to create this prefix file is going to be echo-n gctf and then call it like prefix, right? And now I do fast call -p pref, and that's it. And I let it run. Done. And now I have two more files which are called msg1 and msg2. So what I'm going to do is I'm going to use this xxd-p msg1 I'm sorry, bin sorry, msg, not msq. Okay, this is one, so I'm going to add it to like msg, and then the second one. And this is hex encoded, right? If we would look at the files, one file looks like this, the second file looks like this. So while you can see that they have the same prefix, right? Then this is a little bit different. Like here, for example, this part is different, right? But if we do MD5 sum of MSG1 bin and MSG2 bin, you can see that the MD5s are actually the same. So this is a collision. Okay, and having this in the MSG, all I need to do now is actually let me fix it. Here I need to do this, and here I need to do this to have them on the same line. Hash-meee. And now I can go to Discord to the bot to send it. I'm going to do this off screen. Here, bot. Okay, and I'm going to show you a screenshot of the bot, I guess. Yeah, so I sent this to the bot, and the bot replied with a flag. Hash-meee twice. Okay, and I'm going to put it here. Awesome, do we have all the tasks solved? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Yes, we solved the whole CTF, so thank you for being here. It took a little bit longer than I expected, 4 hours, 40 minutes, but I think it's fine. It's a really great experience, I would say, especially if you're beginning. You should absolutely play Beginner's Quest. This was made with love, and you can absolutely see it. And there were 18 really interesting challenges, which like you should be able to learn something. So yeah, and if you get stuck, you know, you can always jump back to the stream and check how to solve it. So that's it. If there are no questions, I guess we can finish it. Yeah, SQL map lazy. A bit, yeah, Danilo. I implemented blind SQL injection so many times, it's like, yeah, I decided to be lazy this one time. Will I do some Google CTF tasks? Probably no. I don't really have the time to solve them offline, because I would have to solve them offline. So sadly, no. Okay, we can turn this off as well. Am I doing streams like this with other CTFs too? Sometimes, but I haven't had a stream for a long time due to reasons. And but I'm going to probably like go back to streaming early next year. That's what I think. We'll see how it goes. The beginner's quest should be online for a long time, like at least several months, I think. If anything goes down, ping me, or like just write on the official Google CTF Discord. Okay, in that case, thank you very much for everyone who was here and everyone who watched later. Kshaku was my moderator today, and I believe I saw Fox Charlie as well. So thank you, folks, for helping me. There will be no stream on Wednesday. I'm not yet coming back to full-time streaming. So yeah, maybe later in the year I'll do another one. But that's it for now, I think. But I will get back to streaming later on. That's pretty much certain. So again, thank you for being here. And that's it. Yeah, like try Beginner's Quest on your own. It's really fun. So I'm going to leave you with some music and have a great evening, great day, whatever time zone you're in, or great night perhaps. Bye bye.